Alright, it's 11 p.m. in Japan time, so I would like to start the live stream for today. Let me know if the sound is okay. Okay. So, this is Junichiro. This is a Houdini algorithmic live stream, a live stream for Houdini tutorial. It's been doing weekly, and this is 157th episode, and the topic for today is to create a procedural apartment complex building using Houdini from scratch. more of a module-based building system, which I have been inspired by one image of a residential building of Hong Kong, like this one. You might have seen it before. It's pretty famous one, I think. And I just wanted to know how I can create this kind of building as a system procedurally. Okay, so that's my inspiration, where my inspiration comes from. So what I'm going to do is to try to mimic this type of building, procedurally create those building patterns, mostly for facade, and try to create a bit variations on the type of facade you're going to create for each modules, for each unit. For example, the window size and the type could be different, how it's been splitted with the sashes, or you could have some type kind of braces in order to hang your clothes for drying. Maybe you have some ACs on top of the glasses and windows. You have some roofs for each unit, a small eaves, I guess, and all sorts of stuff. I am going to try to make it uniquely controllable all over the buildings. And you might be also able to apply some shape grammar to control, to have more controls over the patterns. That could also be interesting. So that's pretty much it. So what I'm going to do, the step that I'm going to do is to first of all create a grid like this and try to capture the building block and extrude it with some random heights, having each squares on the side as one each unit. And for each wall unit, I am going to replace these rectangles with a custom like facade module system, which I've created inside this subnet, which has various options, like in order to change the window types, having balconies or not, having braces or not, having roofs or not, eaves or not, to change those patterns. Now, if you try to change all units uniquely, that might cost a lot of CPU, that might cost a lot of calculation. So what I'm trying here is to randomize the pattern into few types of units, maybe maximum 10 to 20. So each color indicates the random each color indicates the different types of unit. So having the same color means having the same unit. So if you, by reducing the number of units, you could speed up the processing speed. So as you can see, this type and this type is the same and so on. And in the end, I'm also going to create some ground plane as a road, as well as some eaves on the ground floor, like maybe could be a shopping floor thing. And I'm also going to create some rooftop as well as a simple shape. And that's what I'm going to try out today. It's pretty simple. The idea is simple. I just wanted to test out how I could do this procedurally myself. Okay, so I don't think this is the correct answer to create this type of geometry, but maybe you could see it as one reference. Okay, so that's what I'm gonna try to do, and let's do this from scratch, shall we? As always. Okay, let me open up new Houdini file for this. Okay, so let me save this to today's folder. Okay, so first thing first, I am going to create a ground grid, a plane grid that I'm going to place a base building units. So I'm gonna start by creating a grid, and let's also, since I think I'm going to have tons of parameters to control for this setup, I'm going to create a null node to gather all the parameters that I want to control later. Okay. So, and I'm not sure how much time it's gonna take to implement this, because there's a lot to do, so it might take a really long time. So just be aware of that. I'm just doing this just to recode my process. Okay, so first parameters that I would like to set is the grid numbers for rows and columns. So let's set it. Let's say grid number. I guess I can just make it as a square grid. So I'll just create one parameters and copy it to the rows and columns. So for this value, I'm just going to copy this to a columns as well. Okay. And okay, so now I can control the number of grids. Now, rows and columns. And now next thing that I want to do is to control the size for the width and the height, width and the depth for each grid. Now it's normally when you look at the image of the complex like this one, I don't really know the scale of this unit. Like, let's say this is 1 unit, but what I could guess from the normal, like the standard like building stuff, the height is normally like 3 meters and so on. And if you say that the height, if the height is 3 meters or so, then the width for this pattern could be something like 2.3 meters or something. So let's assume that it's 2.3 on the width and height it's 3 meters. So say grid width is 2.3, but maybe possible to change it later. And let's also set the parameter for unit height, which could also be changed later. Hello everybody. Thanks for coming. Any comments is welcome. So let's say the grid width is 2.3 and the unit height is 3. And now this grid is for the ground, so I would like to set this width and the depth to this 2.3. So in order to do that, I could, let's say, I could do this in Wrangle or transform node. Let's see, what will be easier? Let's just use point Wrangle, shall we? So initial scaling and I currently have this grid width which is unknown yet, which is the size 10 divided by rows or column numbers. So, and the goal size is the parameter that I have just added to this new node, which is 2.3. So let's copy that to a point Wrangle first. So this is a goal value, 2.3. And the current width and the depth could be retrieved from something like using a bounding box size function. So get bbox size and just get the first one. Just get the first primitive, which could be something like this one, this square, and I'm calculating the bounding box size for this square, which you could retrieve the size, the width, and the depth from that grid. Now this is just a square grid, so you could just guess the x or width, x and z will be equal. Okay, now let's create a scale factor to scale this grid to a grid which each grid has width of 2.3. So scale should be vectors, and for the x that will be grid width divided by b size.x, and for the y it's 1 because it's the height direction, and for the z it's grid width, the same value, divided by b size.z. Okay, now after that you can just multiply point position with the scale factors, and it will resize the grid so that each width and the height depths will be equal to 2.3. And it should also work with a square grid, like if you increase the columns to something like this, it should still work the same way. Okay, now but I will just go with the square shape. Okay, so let's increase this grid to something like 50 now as initial grid, and the next step that I would like to do is to pick a silhouette, create a silhouette to capture the outline of the building. Could be just a simple square, could be a really randomized shape and so on. To make facade a bit more interesting, just like I see in this image, I would like to make some noise to a facade. So not just straight lines, but having a lot of like lot of details or a lot of noises on the surface. So to do that, I will implement I'll just start by scattering some points on top of this grid with small numbers, and let's also be able to control that as well. So I'm going to say this is initial point numbers, or and let's say the range is from 1 to 100. And what I'm just going to do is to copy the square, the grid, and I'm gonna make the size to 1 and 1, rows and columns be 2 and 2, and copy this to each point. Now currently the geometry is a bit too small, so what I'm gonna do is to control the scale of each point so that you could have a bigger square to cover the initial grid. Okay, so what I'm gonna do is, I think you could do in many ways. One things you could do, something like attribute randomize for each point, and create a p-scale value which will create a randomized value between 0 to 1 in default, but I'm going to control these values to something like 10 to 30, or maybe 20 to 50, so that some of the squares will merged or intersects. Some of the squares are being isolated to have some interesting diffusion, interesting shapes in the end. Now let's say you could also control the shapes, you could control the global seed, and you might also want to control the range of these minimum and maximum. So let's have that all that as a parameter. So you have global seed and have these p-scale value. How do I name this? Init min scale. I might going to rename this later. And since these are different types of parameters, I'm going to create a separator in between the somewhere around here. Okay. Now going back to a controller, you have additional bunch of parameters. Now maybe for these parameters I could just make it a 1D float. Yeah. Or am I not able to do that? Okay, I have to change it here and change it here, since I'm just using the first values. Okay, and let's also set the minimum and maximum. The minimum could be 0, the maximum could be, I don't know, 100 maybe. Initial seed. For the seed maximum, let's make it 10,000. Point number 100. Okay, so that's fine. Okay, now let's see. So seed You can change numbers, you can change the minimum and maximum. Okay, looks good. Alright, so having these grid intersected randomly, the next step that I'm going to do is to pick the grid which is being covered by these squares. So let's do that. Hi Dungal, please make more videos like this for Architect City. Yeah, I would like to. I'm also interested in this kind of buildings or architectural stuff or urban stuff as well, so I'm looking forward to it. Now, in order to pick up the building part from this initial grid, I'm going to use a primitive wrangles. So connect this initial scaling value grid into a first input of primitive wrangles and squares into squares which represents the building shape into a second input. Now from what I could see, the building shape or building outline is a bit bigger than the grid itself. It's kind of overpassing the grid, so let's try to make the range of the scatter a bit smaller than the original grid. What I mean is that I'm going to make the area where scattering happens to be smaller by scaling this into like half size, like that, and then scatter the point to create a grid, which in the end will assure that you have all the grid is going to be within the initial grid. Now I think I need to change the size for this one, so let's try to make it diverse as much as possible. Maybe I could control this value as well, like 0.7 might be better. Okay, and looking for a interesting shape. Okay, let's try with this. I mean, I want to have kind of an interesting part where you have a small narrowed like hallways, or maybe you might also want to have a hole like that. Could be interesting. So let's try with these first. You could always come back to change this. Now this is currently this shape is not on the grid yet, so we have to make sure that we convert this intersected shape into a grid which belongs to this one. So to do that, I'm going to use a primitive wrangle and look for a distance to the closest primitive from each grid, and if the distance is 0, then you could say that grid is being covered. So XYZ distance, and if the distance is small enough, which means that the copied squares are on top of the grid, then you could say that grid can be used for a building. Let's color it to check. Okay, so let's say this is the outline for the building that we're going to create, apartment complex. And in order to make more details on the sides, maybe you might want to have more details on each corners or on each edges. You could do a similar steps recursively to make the additional details, but for now I'm just gonna go with this one and I'm gonna come back later to have more details. But for now, it's okay. Now let's also set the group, set prim group. I'm gonna tell that as a building. Okay, the next step is to create extrusions, like the walls for each edges of this shape. Okay, so to do that, I am going to use a primitive wrangle. To do that, I'm going to use a poly extrude for that purpose. And I'm just going to set the distance to 1, which will just extrude 1 equally for every squares, but I only want to extrude the building part. Okay, now next step is to use parameters like unit height, which I have set here. So this unit height is a height for each floor, and I also have to decide how many floors you have for each building. In this case, you have 3 types of buildings. One is here, one is this connected big outline, and this one on the left top corner. And let's say I want to have a different height for each buildings. You could also say that I want to have multiple levels on one buildings, but for now I'm just gonna say that if the grid is being connected, I'm just gonna count it as one building, and each building has the same height, same levels. Okay, so the next step is to decide the levels for each buildings. Okay. To do that, we need to know which grid has been connected and which has not. And to calculate that, you could use something like connectivity beforehand for a primitive and only for building, and use class to classify which building is being connected, which grid is being connected as one building. Okay, let's check the value. So you have group building, and you have civil classes. One is -1, one is 738, 650, and 828. Now, -1 is probably the white part, which is because I'm filtering to make a class only for building groups. So let's check the value with the label to make sure that I have the correct value. Okay, so if I visualize the class, so this is -1, this is 650, this is 378, this is 828. Okay, so each one has been splitted and shares the same numbers if it's been connected. It's good. Now, based on these classes, I'm going to specify a random height for each, like connected pieces or connected building. Okay, so I'm going to create another parameters for that, and let's call that maybe an integer. So minimum levels, maximum levels, okay, which could be placed here. So we have unit height, minimum levels, maximum levels. Maybe, and if you're going to use a randomness, you could have a random seed as well. then change it to some big numbers. Okay, so having all those parameters, let's apply those informations to use for poly extrude. You can apply a actual height to the local control Z scale. So this Z scale is being used to multiply the current distance to control the height. So if you specify the distance, the Z local attribute, with the actual height that you want to have for each building, you could have a different height for each units. So to apply that information, I'm going to create another primitive wrangles after connectivity, and let's call this building height. Let's first of all have some seed, random seed value, minimum level, and maximum levels. Okay, and as well as unit height. Okay, and I'm going to copy all those parameters from here. So let's set the minimum levels range from 0 to 100, maximum 0 to 100 as well. Random seed, okay. Now let's set it to some random numbers, and let's copy all these values. So first of all, copy the unit height, paste it to the corresponding parameters on the building height attribute wrangle, as well as minimum levels. I'll just copy the same thing here and replace it to max, and the seed, random seed. Okay, so I have enough informations to create a randomized height for each building. Let's create one. So first of all, let's create some random values using a class attribute, which is unique for each unit, and add it with the seed so that you can control the randomness as well, which will create a float value in between 0 to 1. And what I would like to do is to convert it into a level value from minimum level to maximum levels. So I'm going to remap this using fit01 to min levels to max levels. But for now, this will create a float value, so if you want to have an integer value in the end, you have to convert it into an integer. Let's call this level. I'm gonna use rint, round functions, to convert the float into an integer. Okay, now that I have the levels, the actual height of the building will be the number of level as well number of levels multiplied by unit height. So the actual height, which you have to set it as Z, Z scale. Z scale is level multiply unit height multiplied by level. Okay, let's check. So checking if I have that attributes being created. So Z scale, I have 36, 57, 66. Okay, looks good. Now I also have a Z scale for a white areas, not the building areas, but that's fine. It's not going to be used. Okay, so going back to a preview and going back to a poly extrude, you can now see each building has its own height applied from this z-scale. So you're just multiplying z-scale to a distance, actual distance value, which is equal to 1. So meaning you are only using this z-scale as a height. Okay, that's good. Now the next step is to divide these, each of the height into a unit. In this case, it's the multiplication of 3. The unit height is 3, so we want to create a contour with the height of 3 for each building. Now you could use an option like divisions, but this will only this will apply to all of the extrusions being done for this poly extrude, so you cannot actually control by the height. You have to control the divisions by the numbers, which doesn't work well if you have different height being used, and if you want to divide by the height distance, this cannot be used, unfortunately. Although we do have division scale here, so maybe we could use it. Shall we try it? I haven't tried this one, but this could be used. So div scale, I have also enabled this. So let's see if I can use that one. So currently the divisions is equal to 1. But if I have the height of, let's say 6, you have to have divisions of 2. If you have height of 9, you have to have 3, so on. So the actual division scale should be equal to this level itself. So let's try that. What was the value? Div s scale. So div s scale is equal to level. Let's see if that's gonna work. And seems like it's working. Yeah. Let's try it with the smaller value here to see the changes. Yeah, seems like it's working. Okay, then that's easier. Previously I was trying to use divide node with this option called, what was it, Bricker, but it's much slower. But this one's better. I mean, if you just use this one, that'll be much better, so that's good. Okay, so let's increase the number of minimum levels and maximum levels. And let's try to have a bit more buildings. Let's increase the number of points. Oops, and let's also set the size a little bit smaller so that you have more variety with the building size. Okay. It's a bit hard to control here. Okay, let's try out these. Yeah. And change some random values. Okay. Okay, let's try with these. Okay, hi Town, thanks for the ideas. Sounds cool. Yeah, built by Kaza, huh? Sounds like a good reference. Okay, where was I? So now that I have a base building created, it's time we pick each faces and to create a unique facade or pattern facade. And in the end, I would like to be able to control each of those facade using some rules, maybe using a shape grammar or some with some parameters be able to control outside and so on. So, but for now, I'm going to try to make each unit unique, but not every single unit is going to be unique, but I'm going to try to make some patterns the same, some patterns unique. So let's say in the end I'm going to have 10 unique units for each modules, for each faces for the wall, and I want to spread all those 10 variations all over these buildings. Or maybe each building might have some uniqueness to each other and so on. So there are several options you could think of in order to apply some randomness to each of the buildings, each of the facade. Maybe a north side walls and the south side walls have some different parameters and so on. But for now, as a testing, I'm going to just try to make some random patterns, but maximum in 10 or 20, 10 to 20 as a number of variations for each facade. So to do that, let's also apply some group informations to the side, which are going to be used for the wall. And for the rooftop, I'm going to apply some different groups, which is going to be recreated as a roof later. So for polyextrude, going back to polyextrude, I am going to go to extrusions, and for the side, I'm going to name it as wall. For the front side, I'm going to name it as rooftop. Okay. And let's also change the color for a rooftop for now, so that it's easier to see it. Okay, so the red part, the wall part, is what I'm going to try to modify now. Now, what I'm gonna do is to try to set some random ID to each of the faces, and for each of the faces and for each ID I'm going to apply a corresponding wall unit with that ID. Now, things that you need to be careful is a type that will be applied on the corner, like here and here, which might be a bit different type of unit that you're going to create. Because if the window is continuous, then you might have to consider how the unit's being connected, how the window's being connected on the corner for this side, and also with this side as well. So if it's convex or not, that also matters as well. Okay, so let's try setting the ID first. The most straightforward way to set the ID for each faces is just using some random values for each faces, using like point positions as a seed, or using noise functions as well, so that maybe you could have some smoothness between the units as well, unit changes as well. Maybe in this case I'm going to apply some noise functions for a unit ID. Let's see how it's gonna be done. So I could use the same seed coming from the controller. I mean, noise function could also use a seed in order to change some variations, so it's useful all over the places. So let's have some seed here, and let's create some noise functions based on the point position for now. Later I'm gonna change it, but for now let's do with the point positions. And try to set the color based on this noise values, which is in between 0 to 1, but possibly it'll be in between 0.25 to 0.75 and so on. Now what I want to do next is to convert this noise value into a discrete value, something like from 0 to 10 incremented by 1, to use it as an ID. It will be always better to use integers or string as an ID instead of float numbers, because float numbers could be changed, could be modified with the small numbers. So let's convert this value into an integer using something like fit function. Could be 0, 1, but let's say you have less chance to have a value in between 0 to 0.2 or 0.8 to 0.8 to 1.0. So I'm going to remap this value from 0.2 to 0.8 to 0.1, 0.0 to 1.0, or you could change this part to the maximum value for the ID. So let's call this max unit type. And then let's say if you want to have the unit type maximum 10 unit types in maximum, let's just input 10 here. Then as a result you get the value in between 0 to 10 for using this using this noise function. Now it's still a float number, so let's also convert it into an integer. In this case I'm going to use floor. Okay, and as a result you get integer values, so let's call this type. Okay, now let's apply that value as an attribute and try to visualize that on the wall to see how it looks like. I'm just going to use a color node and using primitive only for the wall, using ramp from attribute and using type, and that is in between 0 to 10. Okay, and let's visualize with some colors. Now currently it's pretty much randomized because the distance between the point is a bit far. So if you want to make it a bit more smoother in between each of the grid, if you want to share, if you want to have high possibilities to share the same units between the closest units, you could multiply this seed value here on the noise functions with some smoothness value, and also add some seed here to apply some randomness. Okay, now if I currently the smooth is 0, so every wall shares the same type. If you increase this one, you're now going to see some smooth patterns on the wall based on the smoothness. And you could also change the seed to change some patterns, which would also change the building patterns as well. Okay, so this indicates that you have maximum 10 patterns, and if you share the same color, you're going to have the same wall unit. Now it's not really practical So probably you might want to make it a bit more higher, so that there are several chances that you are going to share same units with the closest unit, closest distance wall unit, but most of the time it's being random. Or if you make it more higher value, then it's all randomness. So it's up to you how much you wanna make each unit's same based on the distance. Maybe I'll go with 0.2. Now another question, the next step that I would like to do is to share the same type for the corner pieces. Especially for these types, I could see that this wall and this wall shares the same unit, right? So this has to be one room. And probably you want to share the same attributes for this walls and this wall, especially if you're continuing the window. If the window size is different with this size and this size, you might not be able to create a smooth connections between these two corner walls. So what I would like to do next is to share the same ID for the corners. For these corners, maybe you don't really need to care, but for this one, for the convex corners, you might want to have it. So to do that, one thing you need to change with this implementation is where you set the seed for the noise. If you set the same values, you get the same results for the seed. So what you need to do is to set the same value for this value and this value, which currently using P, which as a seed, so each one gives you a different result. So you have to change this part somehow. Now the part you could change is probably the X and Z value, the horizontal plane information value. You could remain the height of this P as it is, but for the X and Z, you could, let's say you could just set it as a center of this closest floor grid or ceiling grid. So just copy the X and Z value of this center point for each panel on the corner. And for the Y, you can just set the center of these plane. Then you should be able to share the same value for the corner values, and also no problem with all the other places as well with the same logic. Okay, so to do that, we need to have a reference for this grid, which can be retrieved from the initial grid, which is this one, I think. Yeah. So let's name this initial grid which you might going to use this a lot of times. And let's bring this as a reference with the object merge node, and refer it on the second input with this primitive wrangle 2, which is currently changing the type. So let's name this wall type. Okay, and what I would like to get from the initial grid, which is a floor grid information, the original floor grid informations, I would like to get a corresponding grid center point positions for each wall position. To get the corresponding positions, first of all, you get the X and Z value for each wall, which is on the center of the wall. project it on the floor, meaning set the y value to 0. Then look for the closest grid, which is set as a wall grid. Now I realize this might not yet have a wall group yet, so maybe you might want to use this one instead. Yeah, this one instead. Okay, so this grid, this flat grid has an information which one is the wall group and which one has the ground group. Okay, so let's check the attribute. So we have a building group. Yeah, so we're going to use this building group as a guide, which has the red color on the floor. Okay, so first thing to do is to copy the point positions on each wall. Okay, which is the center of the wall piece, the wall grid, the wall square. Then set the y value to 0 to project it on the floor. Then look for a closest primitive to the reference, okay, for this projected positions by using XYZ distance, using projected point positions, and get the primitive and UV. And you also have to filter the group by building. As a result, you should be able to get the corresponding building primitive numbers from the second input. Now you can retrieve the point position of this of the grid center. In this case, if you're looking at the corner walls, you should be able to get this grid, and the center of the grid can be retrieved by using a prim function with the p attribute. Then in the end, you might also want to control, you might also want to update the y positions to the original y position of the wall. Okay, then you could replace this add p by the center to recreate the noise functions, the noise value, which in the end you should be able to get the same value for this wall and this wall. And if you are having the same color for the corner, it's been successful. Okay, and for the these corners, when it's not a convex corners, you're going to have a different types of groups, which is fine. But for convex corners, you are going to have the same IDs, which is important. Okay, looking good. Okay, so that's good. Now that I have an ID or type information, I would like to use these to set some patterns on the wall based on those patterns, based on those types. So let's say this is the preparation part. The next step is to actually create a wall pattern, which could be implementing windows, eaves, all sorts of like equipments, like AC, air conditionings, and maybe balconies as well, and so on. Okay, and you should be able to choose which part. You should be able to control like the size of the window, if you want to have AC or not, the position of the AC, and all sorts of stuff. And yeah, let's try that. And preferably should be able to change those patterns using like simple parameters or a shape grammars or something like that. Okay, so let's try that. Now, let's create one simple unit first, then try to make it extended later to be able to connect with these patterns later. So, starting with the simple grid, and let's set the size to let's set the orientation to XY plane, set the rows and columns to 2 and 2, and for the size I'm going to use a unit size that I have set here. So the width is 2.3, so the X size is 2.3, and the height is, the unit height is equal to 3. Now in reality, maybe each building has different unit height, so in those cases you might need to also control those randomly. But for now, I'm gonna make it as a uniform value scale for every building. Okay, now let's say this is the single unit that what I would like to control here. Okay, now let's start creating some. Let's start by creating something like window. Okay, so I am going to assume that each walls has a window, and there might be a chance that some of the walls might not have a window in some cases, especially when it's related to bathrooms and so on. So you might also need to have some option if you want to have a window or not. But let's say most of the time you're going to have a window. So let's create a setup for the window first, shall we? So to do that, first thing first, I am going to place the floor of this unit to be set to a 0 coordinate for the Y. I'm just going to use a match size to bring up the bottom to the 0 by justify Y to minimum. Justify X and justify 0 could be unchanged, so I'm gonna set it to none and none. Okay. Next, I am going to set the group to this plane as a wall. Okay. Now, let's see how I'm going to create a window. I mean, there's so many ways to create a window. I mean, if you're just using textures in order to visualize the walls and windows and stuff, you could just create a simple plane on top of this grid and say that it's a window, and you can just paste the window textures on it, and maybe in some case that's okay. But for this tutorial, I'm just going to create a model as is. I'm going to create a sash as well. I'm going to create a window shape as well. Everything will be modeled instead of using textures. Okay, even though it's going to be really simple, just a square based shape, but I'm going to model instead of using textures. Okay, that's one thing that I'm going to do here as a reminder. Okay, so to create a window shape, let's see how I am going to do that. Let me check how I did that. So for the window, I'm going to create a box shape, box that is the size of the window, and using some boolean to create a hole to the wall. to create a window shape. So to do that, you need to have a box shape, okay, to control the size of the window. I'm going to create a simple box, which is 1 by 1 in terms of the size. And let's also use the same match size so that the bottom of the box will be raised up to the ground, like that. Okay, now what I would like to do is to control the size of the and the position of the box, which is going to be used to trim the wall to create a window from here. So I'm going to use a point wrangle to control the size and the positions of this box shape. Okay, so I'm gonna call it as window size here, and I'm going to also connect the wall shape to a second input of this point wrangle as a reference. Okay, so let's first of all get the minimum and maximum, the bounding box position, the bounding box information from the second input. Okay, and let's create some parameters in order to control the size of this box. First of all, the height of the window. Height from the floor to the bottom of the window. Okay. So let's try to use that to use this value to raise up the y value first of all. Has to be plus equal. Okay, so now you can raise the height of the window. Sometimes it could start from really low if you're working with a balcony type window. If it's a normal type of window, probably in Japan it's probably something like 0.70 centimeters, and some in some other countries it might be higher, it might be lower. Let's say you have some options to choose from the value. Now the next step, next value you want to specify is the actual window height. Now this is not the, should change the name of this one. How do I call this in English? Oh well. I'll just say window height 1, window height 2. Okay, oops. And this is for the 1. I should delete the previous one. Let's set the range from 0 to 3. Okay, now let's set the first value to be 0.7, and let's say window height 2, which is the actual height of the window, to be equal to 1 for now, meaning 1 meter in this case. Now in order to apply this value here to, let's change this value to 1.5 because the default value is equal to 1. Okay, so in order to apply this window height to this box, what you could do is to, before adding a height, you could multiply the y value, which is the height value, by a win height 2. Then you could control the height of the window, then you can raise up this height. Okay. Alright, looks good. Then the width. You might also want to apply control the width as well. Now the width could go over the shape so that you could have a continuous window throughout the next walls, or yeah, you could have some margins between the sides as well. Now I am assuming you could have both, so let's try to create some options to be able to choose whether you can go over or not. Okay, and to do that you could make a reference to the current size in order to control the offset. So let's get the current width or current minimum maximum, which is this one, and use that information to control the width. In this case, I'm not going to apply the actual width, but I'm going to calculate the offset from the side of the wall. So here, from here to here, I'm going to specify the distance from those edges. So first of all, I'm going to create some values. Let's say would like to have some margins of 0.1, like 10 centimeters from each side. What I'm gonna do is to so first of all, calculate the size of this original wall here, which you could control, which you can calculate from here, but you could also get the value from get bbox size, which is simpler. Okay, now the goal size of these points can be calculated by the scale. So create a scale factor, which is just a float value for the x, and the goal size is the whole with x divided by 0.5, multiplied by 0.5, because you're looking from the center and you're looking at the radius here, minus with offset. This will be the goal size of the window for half size. Okay, divided by the actual wall size. Is it? No. Actually, you can just divide it by 1. So this is actually the scale value. Wait a minute. The box size, the current box size is equal to 0.5 for the half size. So actually you have to divide it by 0.5. Okay, so this should be the goal scale in order to apply it to the box. So let's try that out. Maybe not. If it's 0, it has to be filling the whole space. So I think I'm doing wrong here. So the wall size, okay, has to be getting from the second input. Okay, now it's filling the space, and if I increase the width offset, I'm going to have some margins here, and if you make it 0 or negative, you're going to trim the whole shape. And you're going to have a continuous window shape. Okay, so yeah, should be good. Let's keep it to 0.2 for now. So we have a bunch of parameters to control these. Now I'm not going to apply this to a controller as a global parameter, because these values is going to be varied based on the types you're going to choose for each wall. So these parameters it's going to be changed based on the difference of the type. Okay, so for those types, it's not the global parameter, but it's more of a local parameters. Okay, now that I have set the size of the window, let's create the boolean. Okay, and to use a boolean, I'm going to connect the walls to the first input, the boolean, which is the surface. For the second input, I'm going to put the box as a solid, and I want to have both the inner squares and outer trimmed shape at the same time. So I'm going, instead of using subtract, I'm going to use a shader, and going to apply a group to A inside B and A outside B. Now A inside B is the actual window shape, so I'm going to call it as window, and A outside B is the wall. Okay, let's check by setting the color to the window. So for the window, so this is the window part we have. Okay, and the next step is to create some sashes and the glasses plane to this single grid that I have right now. Okay, it doesn't have to be really detailed, but I'll try to make it more of a simplistic shape for the window. So first step, I'm going to create some depths. I'm going to create some extrusions to this window so that you have some depths for this window. I'm going to use poly extrude to start off and apply it only for window. Create the distance to the negative directions, and for this step it could be globally controlled right here, or maybe it could be just fixed and you don't really need to change it otherwise if you don't really care about it. So let's just call it a fixed value. I'm not sure if the 0.2 is too deep or not. Let's go with negative 0.1. Okay, now next I'm going to, let's say, what I am going to do next is create some sashes, I guess. Okay, so let's try doing that. To do that, I need to specify where I'm going to have a sash, or if it's like a cross grid or grid which looks like a vertical grids on the bottoms, and you have horizontal grids on the top, and just like these, so on. So we have to, and some cases you have different types of splits, different types of sashes. Okay, so let's try to make it procedural so that you can control the types of splits for each window based on some parameters, shall we? So to do that, we need to apply some logics. Let's see where we can do that. And to do that, going to let's see. I'm going to use some wrangles to control the shape. Now, there are several types of things you could control in terms of sashes. If you have a grid, if you have a single squares, first thing you want to do is to how you want to split the squares in vertically, meaning maybe you want to split like this, or you might want to split like half and half. You might want to split like that, or you might want to keep it as it is. And the next step is to define the horizontal split for each squares. Like if you want to split in 4 for the first squares, and maybe you want to split into 2 for this one, maybe for this one you might want to split into 3, 2, and 1, or you might want to have a crossing split, or maybe you just might want to have just one single square as it is without no splitting. Okay, so these could be an option or sashes, and you might want to be able to change those based on some parameters. So let's try to think about what could be the parameter for this. Okay, so for the vertical split, like these one, I think I could define the vertical split by specifying the ratio between the squares. For example, for the left hand side one, it could be 3, 1. For this one, this could be 2, 1, 1. This could be 1, 1. This could be just 1. And let's end in one letter, or in one word, you could say these is the rule for the vertical split. Okay, and for the horizontal split, in this case you have a number of split for each layers. For example, for this layers you have 4 horizontal splits. For this layers you have 2 splits. For this one you have 3, 2, 1. For this one you have 2 and 2. For this one you have 1. So as an additional information, you could say 2 for this horizontal split. This could be 3, 2, 1. Or split, horizontal split. This could be 2, 2, and this could be 1. So the number of split is equal to the number of ratios you have. Okay. So that's a basic rules you could set in order to think it as a procedural stuff, procedural like sash shape. So let's assume we have 2 parameters. One is the vertical split ratio, and one is the horizontal split numbers. So the meaning is a bit different, but I think with those 2 parameters you could create more of a controlled sash shapes. Okay, so let's try doing that by search slicing floor plan. It's a technical name for these split. Okay, it's a slicing floor plan. Thanks for the naming conventions. I didn't know that. So let's use primitive wrangle, and okay, let's call this slicing window slice. Oops. Okay, and let's start. So should I use primitive wrangle? Is it? Yeah, I think so. And we're only working on the window, so filter it with the window. Okay, so let's have those two types of parameters. One for the vertical ratio, split ratios, slice ratios, and one for the horizontal slice numbers. Okay, so let's call this string b slice ratios. I'm gonna use it as a text string parameters for this one. And another one is horizontal slice numbers. Okay. So let's just set some random numbers for now. Let's say 3 by 2 by 1 for the vertical slice ratios, and for the horizontal slice numbers, let's say 4 by 4, 3, 2 by 3. Okay. Now let's try to use these to actually slice these squares. Okay, so first thing first, I am going to bring this up inside of Xcode and use it as a numbers. Currently this is a string, so we have to bring this as a numbers first of all. So first of all, I'm going to split the text coming from this parameters by the colon. Which will give you a string array. Now, string array is still not enough because we have to use it as a numbers later. So we'll do that later. And we have h slice doing the same splitting. It doesn't have to be colon, or it could be comma, it could be anything if it's separatable. And next, let's get the window size informations by getting the bounding box informations. Get bbox from the window size. Okay, now first of all, let's start by creating a vertical split, shall we? So I'm going to create a loop for a v ratios. And currently we have a string value called v ratio, but we have set it as an integer here, so we could convert it into a integer from this string. So I'm going to convert it into integer by a to I or a to f maybe. Let's change this to float. Okay. Now, in order to use it as a ratio, we need to have we need to add all these numbers together in order to actually be able to use it as a ratio. Meaning 3 plus 2 plus 1 is necessary as a pre-calculation in order to actually use these values as a normalized value. So in this case, 3 plus 2 by 1 is 2 plus 1 is 6, and if you divide 3 by 6, it's 0.5. So you can guess from that it's a half size of the whole shape. And if you divide 2 by 6, then that's 1 divided by 3, so it's more like a 33%. And if you divide 1 by 6, then you have the rest of the ratio and normalized. So in order to make everything normalized, you need to first of all calculate, you need to add all these values together before actually using as a ratio. So what I'm doing here is getting the total ratio value, calculating the total ratio value by incrementing by the value that I have here. Okay, then do the same loop, but next time I'm actually going to use the ratio divided by the total ratio, which in this loop the value has been normalized so that it's more easier to use. Okay, so let's this is for the vertical split, so let's use this value in order to actually calculate the height, the bottom height and the top height for each window, the splitted window, the sliced windows. Okay, so okay, and for each time I would need to change the y ratio. So let's start the y ratio from 0, shall we? Which is the bottom. Let's say this is bottom part is the 0 and top part is the 1. Okay, and the 0 position correspond with the minimum. The 1, when the y equals 1, the position correspond with the max dot y. Okay, so the bottom of the y for the first sliced window can be calculated as converting the y ratio into a value in between minimum and maximum. So you could use LARP from min y to max y using y ratio, and for the y2, that is min y max y between using this v ratio. And for the next loop, you're going to increment the y ratio by the v ratio. Okay, now that we have the bottom y positions and the top y positions, we could start by creating some squares, splitted squares, using these information. So let's try that somewhere around here as a test. This is just a test. So in order to create a square, we need 4 points. So one, we need to create 4 set for this point, and using add prim to create a connected primitive using these 4 points. Okay, so for each point we need to set the coordinates. Now for the first point, let's say we start from this point here on the left bottom corner. The minimum the x will be either minimum x or maximum x in this case. So minimum x, y, and a minimum x for the x value, and for the y value, use y1. For the z value, just going to use the current window z value, which is min z, I guess. Min z and max z is the same value, so you could just use anything. And for the input point number 2, I'm going to use max x, y1, min z. For the third point, max.x y2 min z. Fourth point, min.x y2 min.z. Okay, and do I have it? And after doing this, I'm going to remove the current primitive current window shape. So remove prim. Okay, something is not right. Let me disable this. Okay, something might not be right, so let's see where I did wrong. So I have a V ratio. Okay, should be correct. And from minimum y to maximum y, yeah. And let me just break this loop in an initial setup and see what's happening here. So the first loop, it's creating a grid from 0 to the half size, which seems correct, which corresponds to this one. The next, for the next loop, I want to have the bottom of the y to be equal to the previous y value, which is this one, right? And previously the y ratio was 0, so I think on the next loop should be something like that. Let's check. Oh, one thing I forgot to do is I have to do something like this, I think, and yeah, I should do something like that. Okay, so when I is equal to 1, you're adding another layers, which is corresponds to this value. So yeah, the 2/3 of the size of this half size. And finally, when you do all the loops, wait a minute, why am I not getting the last one? Why am I not getting the last one? Previously I had 6 and deleted 1. I should be creating 3 plane, but I don't see. Oh, here it is. Now maybe something's still wrong. Maybe right here. Did I have to? Oh, okay. Sorry. I still had to, add this V ratio to the Y ratio. I have to update the Y ratio recursively. Yeah. That I forgot to do. Okay, yeah. So seems like the vertical split works. So if I change these values like 4, 2, 1, you should be able to control the split based on those values. You could increase the number of splits like that, 4 by 1 by 1 by 4 and something like that. Or if you want to have just 2 splits, could work. And if you have just one value, it's just the whole shape. Yeah. Okay, so seems like the vertical split works. Now's the time to go for the horizontal split. Now, one thing to be careful is that if you have 4 split, if you have 3 split, you also need to have 3 splitting numbers. In case you have only 2, then maybe the rule could be that the last value should be used for the last vertical split ones. So in this case, for the first grid will be splitted into 4, the second will be splitted into 2, and the last one using the same last value. And if you have more than the vertical split, then the last one is not going to be used. Okay, so that could be a error-free implementation for that. So let's try with these setup. Try to use these numbers for the horizontal split somewhere, and that should be within this loop. We're going to create another loop within this loop for the horizontal split and update these functions to create the plane. So and this is, for this one you have to specify the number of split which comes from these numbers. So let's also get these numbers inside this loop as well. So horizontal split numbers is A to F, B H slices, I, yeah, and this could be integer. Now, thing is, if the I value is more than the number of arrays, in this case you have only 2 items, but if you specify the last index for this array, I want to be able to use the last one. So to be able to do that, you have to make sure that the I is less than the total number of the H slices. Something like that. Okay, so to make sure that you always use the last one. Okay, so this gives you each split values for each loop for the vertical split. Now let's use this number to create another loop. Like that. And in this loop, what I would like to get is the x1 and x2 corresponding to these values. So float x1 and float x2. Now x1 should always start from 0, so like I did for the y ratio, I'm going to create a x ratio. Okay, now for the horizontal split, it's more of a equal size splitting. So the actual size is just the simple divisions, I think. So the x1, probably you don't really need to have this value because you're not really incrementing any value. So for the x1, that will be, let's say, n divided by h num. That's it, probably. And you might want to make it as a float. And for the x2, that is n plus 1 divided by float h num. Okay. And these are just the ratios, so you also need to convert it into a positions, just like I did here. So using lerp min.x, min.max.x, and using this as a ratio, lerp min.x, max.x, the ratio. Okay, now I could replace these values with x1 and x2. Let's try x1 here, x2 here, x2 here, and x1 here. There you go. And now you have splitted the window, sliced the window, just with the parameters you set here. And if you have 4 by 2 by 1, you have 1 glasses, 2 glasses on the second row, and 4 glasses on the fourth row, a third row. And you could have exaggerated numbers as well. Yep. So with these values, with these two values, I think you could have variety of patterns. Like if you just want to have a crossed window, this will be the value, I guess. If you just only one, this will be it. If you just need a horizontal split, this could be it, and so on. Yeah. So that's good. Okay, now that I have a base split for the window, let's create a sash and window glasses as a simple square shape. Okay. So creating a sash is pretty simple. I'm just going to use a bunch of poly extrude. Also, I want to make sure that the polygon that I have created here have a window group. Okay. And also checking back the extrusions that I have here, I want the side to be wall, the front side to be window. Okay, just in case. Okay, and recolor it to check which one is the window. Okay, so it looks correct. And let's also recolor it after the slicing to check. Okay, looks good. Now, for the windows, first thing to do is to have some gaps between the sash and the wall shape, or maybe it could be maybe I'm just going to extrude it on the depths part. So first thing to do is to create some base sash width. Using poly extrude for the window, I'm going to set the inset here, which is going to be used as the size of the sash here. Now normally you would have additional sash outside this window sash here, so this is not really correct, I guess, but you know what to do. If you want more detail, you go for it. Okay, I'll just go with the really simple setup. Now let's just set some inset to 0.03 or something. Maybe this could be controlled from parameters, but I'll just fix the value as it is for now. And for the front side, this is still a window. For the side, I'm gonna name it as sash. Okay. And then give another poly extrude to this time extrude with the distance for a window. Gives you some depths. Well, let's do this to the negative directions, like that, to have some depths like that. So let's say 0.03, and set the groups again. For the front, this will be window. For the side, this will be sash. Okay, now let's recolor this. The window part is just the glass, so maybe I should have called it glass. Yeah, so this is glass. And for the sash, let's color it to something different, like darker colors. And yeah, maybe that's too dark. Okay. Yeah, so the base setup for the window is something like this. So you can control the window size, the height, offset, as well as those slicing ratios. Okay. Okay, now at this point I would like to try to bring this patterns onto each of the walls. It's not really complete yet, but let's try to place this window to each of the wall to see how it looks like. And to do that, I also want to make sure that I could also change the parameters for each wall as well. Okay, so we need to consider about that as well. So to do, meaning that I need to call this logic for a number of patterns we have. If we have in total 10 types, 10 type patterns, then you have to call this 10 times maximum. Not the number of actual windows, but not actual walls, but the number of types. Okay, in order to effectively call the logic. So first thing to do is to gather these logics that I have here for the wall pattern as a subnet, so that it will be easy to call from outside. So I'm gonna select all these node network and click the subnet to create a subnet network, and let's call this wall pattern. And preferably I would like to have all those parameters that I set for this subnet pattern. So you could create additional parameters here for the subnet in order to control the inside shape. So let's try doing that. In this case, what I could control is these 4 values and these split values. What else? That's pretty much it. I mean, you could also control the extrusion values as well, but that's a bit too small issues. I'm just gonna go with the fixed value. Okay, so these are the important values you could change. Now, now let's think about how we could apply this wall pattern to each of the wall. Okay, so we currently have a walls with the different type IDs shown as the colors. So first thing to do, I'm going to create a for each named primitive to access each walls which shares the same ID. Okay, now right here I'm going to split the geometry into walls and the different geometries. So I'm only going to work with the wall right here right now. So connect the wall shapes to the for each loop and set the piece attribute to type. Okay, so we have in total 10 types, so we have 10 loops, and each loop we have uh, walls that matches with these type. This is the last type I'm seeing right now. And if I look at the geometry spreadsheet for these collections, the type is 9. So every wall should be sharing the same wall unit in this case. Okay, so so for each loop, I could create a new type of wall pattern using different parameters, then apply it to each of the wall positions. Okay, so to apply, I think using copy 2 points is the straightforward way, so I'm going to use this one. And in order to use this, you need to have a point position, the copying positions, and the distant direction. In this case, normal directions and up direction, I think. So let's first create a normal and up directions for the copy 2 point from these wall that I'm going to copy the pattern to. I'm going to create a prim. For the normal, I think you could first of all create a normal value from the faces for the primitive, which will give you a perpendicular directional normal for each faces, which can be used as a normal direction for the point as well, for the copy 2 points. For the up vector, for the up distance, it could just be a y distance, y directional axis value. So that's pretty easy. So primitive wrangle for each shape, for each wall. Let's get, first of all, let's get the type, which is a type. Maybe I don't need it. Let's get the point positions and add the new point. The point position of the face, the center point position of the face is just at P. This is just a simple square, so you can just get it as it is. And set the normal directions to this point that I've created, just copying the primitive one. Also set point attrib, set the up vector value to 0, 1, 0. Okay, and remove the original geometry like that. Okay, now check the normal directions. Okay, so first of all, let's check if I can just copy this wall pattern that I've created with a bunch of parameters to the corresponding wall positions, if that's gonna work. Let's see. So doing like this. And now, yeah, I think it's working. So every pattern is the same, so it's not really interesting. But at least it's not, the direction is not the flip directions. We have to change the normal to negative. Yeah, so this is the correct direction. Okay, so every pattern is the same currently, so it's not really interesting, but if I change this pattern here, everything will change. And it's decently fast because you're only working with the 10 units. Everything else is just instanced or copied, so it's not that heavy. And if you even pack it, it's even faster, I think. Like that. So it's up to you for that, but for now, just connect it. And the next step, let's try to change those parameters based on the types. So maybe randomly set these values using these type attribute. Okay, so how shall we do that? We could There used to be a stash or stamp, but currently I don't see a node like that, so I'm just going to create a parameters for each types, these 5 different parameters for each types within this loop. Okay, so maybe after creating the point, let's create additional wrangle or something to set some custom parameters for each type. Okay, using point wrangle. So in this case, I think it's also a good idea to pass the type attribute as well. Okay, so check the geometry spreadsheet point, and if we have a type, that's good to go. So let's use this type as kind of a random seed to create some random values for it. 5 different values, shall we? Okay, now so, and we could also use additional seed values like this one, so I'm going to copy this random seed here, and let's bring that seed value here, and first of all create some random values. By using rand functions, using seed plus type. Okay. And I think we need 5 different random values in order to use for 5 different values. Now I'm wondering if I have an option to create a random arrays on Vex. Maybe not. Let's just check. Random non-deterministic. No, that's not it. Random 0. So I mean, at least you could create a vector for randomness, which gives you 4 different values, but it doesn't give you an option for arrays, so I'll just go with 5 different parameters. It's kind of a cumbersome to write this line 5 times, so maybe I could use for loop. I'm not sure. Maybe. But anyway, yeah, maybe use for loops. But I have to make sure which index stands for which values. Well, let's say this value is for index 0, 1, 2, 3, 4. Okay. So oh, wait a minute. Although each value has different types, as you can see, this is float numbers, this is string. So actually, it's a bit hard to mix different types, variable types in one array. Oh well, I'll just do 5 different randomness then. So I'll just name it as win height 1, win height 2. Something went wrong with my display. Okay, now it's fixed. Okay, when with offset, I need to also change the seed, because if you do this, then you always get the same value, which is not preferable. I mean, you could use n random functions, which gives you a non-deterministic randomness, but then you doesn't have a control over the seeds, so it's not a good idea. So B slice ratios. And what's the last one? Age slice nums. Okay. Okay, so for each of those stuff, I need to change the seed for some value. So I'm gonna add additional random values to each of the value, so that I'll always get different value for each 5 stuff, each different values. Okay, something like that. And and then after that, some of the value has to be remapped, some of the value have to be converted into string, and so on. So let's do that. So for the random window height, which is currently from 0 to 2, let's set some range for this one. So let's say it's in between 0.5 to 1.5. So I'm gonna use fit01, and I'm gonna use a min val1 or min win height 1 max win height 1. Okay, do the similar stuff for the second one, the second window height. For the third one, the offset, that is in between 0 to something. So yeah, let's go with the same setup. Fit 01. Okay, this has to be 2. For this one, min with offset max win offset. Okay, now the tricky one is the split ratios. So how do I enable this with the randomness? Maybe you don't really want to make too randomish for these values, but maybe you want to control how much these values should be. So one thing I could think of is to create some template for these patterns and just choose a random template from the one you have prepared. For example, you could have 3, 2, 1, 3 and 2, 1, 1, just 1 as candidates, and just choose one of those template from those candidates randomly. Same for the horizontal slices as well. Okay, so for these one, let's create some arrays. So v slices. And let's check as a parameter if there is a way to create a arrayed string. So we have a label here. It's not a string. We have a string here. Let's see if I can bring it to here. And so this cannot be created as a array, but at least you could create a multi-line string. So maybe let's try using this. Okay, and this is for the v slices. And additional parameter will be a hnums. Okay, again, multi-line string. So what I'm trying to do here is to create a kind of candidates for slices, like 4 by 3 by 2, 3 by 1, 1, and I don't know, 4 by 2 by 2, something like that. Same as 2 by 1 by 1. And for the split, let's say just 1, 2 by 1 by 1, or just 4, or 3 by 2 by 1, 4 by 2, and so on. Okay, so I'm going to try to mix these randomly. Randomly pick from these arrays, randomly pick from these arrays, and combine these two. Okay, I mean, you could add additional like logics to yourself, but for now I'm gonna go with these. So v slices can be retrieved from the string, so chs v slices string h nums yeah. Now I need to split it into 4 different string values based on because it's the multi-lined value. So let's do that by using split function, and I'm not sure if it's possible to use, but hopefully this is the returned character, meaning new line. Let's check. Split. Okay, so let's check if we have got the correct string array value by checking on the geometry spreadsheet. Okay. Checking the point attribute. Wait a minute. Was it? Oops. Checking at the point attributes. We have, oh yeah, we do have a string array, so it's successful. Cool. Alright. That's cool. Now, then I could randomly pick from those items from those arrays and use it as a parameter for this node, for the subnet. This one and this one. Now I do see some white lines on the end, so maybe I need to trim the string. Do we have that? Nope. Concatenate, no. Decode, encode, no. Join, match, odd, pluralize. I wonder. Okay, maybe something like this. Leading and train. Okay, so this one. I need to use this one for the item on the array. If you look at the items on the string array here, you see some white space on the beginning of the value. You have to trim that, yeah, in order to use it. Okay. Okay, now let's convert this randomness into an index for these arrays. So I'm multiplying it by the number of v slices and calculate the floor so that it will be an index between 0 to the number of v slices minus 1. Do the same for this one. Multiply by the lengths of h nums and using floor to get the index, and then pick the string value from the v slices, pick the string value from the h nums, and then finally using strip to remove the white space. Now that's a long line, but what it's done here is pretty simple, and so the final value will be string. Okay. Okay, let's check. So these values should be a single string. Hopefully we'll get these values as a randomly picked value. Okay, so yeah, randomly picked. And well, where is the h slice? Okay, so, and if we change the seed value for this one, you should be seeing some different values, just like that. Yeah, okay, looks good. Looks good. All right. Now, going back to the code, it's time we set some values like minimum window height for, and let's call this, I don't know, 1.0, the actual height 0.7 to 0.5, the minimum offset 0 to 0 to 10 or 0.5. I'm thinking if I should make these values discrete so that you have a limited number of options, but it's up to you. I mean, for now I'm gonna go with these. Okay, so let's go this 0.1. Okay, so I now have those values. The next step, it's up to how I access the values, but maybe accessing through the attribute might make sense. So let's have all these values inside a attribute. So we already have these slices numbers, and the next step, let's bring these into a attribute. we have a random height. Let's not call this randomness, shall we? And the rest of all. Okay, so we have 5 different values now. Now let's access to this attribute from this wall pattern. Now I'm gonna name this value into a wall info, so it's way easier to refer to. Then on the wall pattern, I'm just going to replace this value with an expression. Okay, so that's a point attribute, so point at wall info and 0. And what was the name? What's the name of the attribute? So the wind height 1. Okay, and let's copy this to here. And this is for wind height 2. This is for the width offset. Okay, and this is for the V slice ratios. Now this is a string, so you have to name it as point S, I think. And point S has a different number of parameters, I believe. How many numbers? Doesn't give it an option. Well, I think it's just 2 or 1. Forgot. Yeah, it's just 1. 3. I mean. So. Oops. Let's copy the name of the attribute. The first 0 is the number of point. So let's see, go to 0, and the second 0 here is the coordinate number. If it's vertex, if it's vector, it's x, y, z, meaning 0, 1, 2. But if it's strings, you don't really need to set anything. So this should be the way to write it. And I'm not sure if it's going okay. We'll see it. And finally, age slice nums. Okay, so hopefully we got the, okay, maybe I'm not getting a value. Maybe I'm doing something wrong here. Let's replace this to 3. Let's see if I'm getting something. Okay, so maybe the expression was wrong. Let me check. Expression functions. Point S. Surface node point number attribute, so looks correct. What's wrong? Okay, so let's try this again. Point S. Wall info 0. Maybe I need to use a back quote. Oh yeah, that's it. Since this is a number attribute, is it? Yeah, this is a number attribute, so I needed to convert it to an expression using backquote. So for the horizontal one, use this one. Okay, now if I leave the loop, you're going to have 10 different window types being applied to each of the wall based on the type value. Okay. And from here you could modify the minimum and maximum, like maybe the minimum height could be bigger, and you might want to have at least 2 divisions, and so on, right? Okay, I mean, it's up to you how you change it. Okay, so for now, and all the rest of the stuff that I'm gonna do next is pretty much this with the same process. Just create some patterns that you can control for each walls, and try creating some random patterns based on the type inside this for each loop, and use it for the pattern. Okay, and so that you're only just using 10 loops, you're just creating 10 wall patterns, but you can effectively you can effectively like shorten the process. You can effectively cheapen the calculation cost. It still looks randomish, even though you only have 10 patterns. If you want to increase the patterns, you could always go back to the wall types, increase the wall max unit type, like 100. Now you have 100 types. And what is this line? What is this line? Oh, it's just the wireframe. Okay, so yeah, it's up to you how many types you want to create, but I think 10 to 20 is enough to see the variations. Yeah. Now, so that's for the window, and let's keep developing the wall pattern with the similar logic. Okay, going back inside the subnet, and let's also hide these. So let's see what could be the next. Now, next step, let's try creating some eaves, like a small roof to each of the window to have some like to block from the rains and stuff. Shall we? So let's organize this a little bit. So this is more of a window shape, right? Now above the window, I'd like to create some eaves. Okay, so let's start by thinking about having without any window. Like maybe in some chances you might not want to have any windows at all. So let's give that options. Let's as well. It's pretty easy. You just switch between the flat walls or the walls with the window. Right? So it's pretty theoretically it's pretty easy. Now I have a wall here, and I have so this is the part where I'm creating a window here. So probably I could switch between the one that has a window or the one without the window with this switch. Like that. Okay. So let's make sure that I'll be able to control whether I could have a window or not with this switch. So going back to this wall pattern, I am going to add another parameters. like integer in between 0 to 1, and option to use no window. Okay, and if it's 1, you have no window. So let's copy this value and go inside and use it right here. Okay, so you can toggle between 0 and 1 here. Now let's have that as a type wise value, just like I did for any other values. So in this case, I could create additional random values here. No window, which is either 0 or 1. So let's create it as an integer. And random seed, we have random seed using different value here. And instead of using remap function, you could compare with the threshold. Okay, so it's more like a percentage, like no window ratio. If this is high, then you have more chance to have no window. Okay. So currently it's 0, and I have to give it as an integer value, as an attribute, like that. Okay, and then reference to that value from here. Wall info. What was the name? No window. Okay. Now, if I increase the ratio, you have less chance to have windows, and if it's set to 1, nothing, everything is just the wall, no window at all. If it's 0.5, you have 50% chance to make it as a window, and so on. Okay. And these conditions could be based on some, like, I don't know, directional conditions on the sites. Maybe if it depends on where you live, where the building is placed, it might be make sense to have more windows when the sun rises up, when the sun comes up, when you see the sun's directions. And normally in Japan we don't have much window on north directions, but most of it on south direction. So that kind of logic could be used here instead of using randomness. Right? Okay, so where were we? So let's create some eaves, some simple eaves, shall we? Just wanted to make more chaotic, like residential facade, just like you see in this splendid photo. So what I'm doing here is just trying to mimic those kind of feeling. I mean, in the end, you might also need the textures, but I'll go as much as I can to do with the modeling part. Okay, what else? So eaves. So eaves must always go above the window, so we do need to have some window information for that. So let's see, where can we get the window boundary size, which is this one. Okay. So we could reference to this box as well as the whole wall shape. And having these two informations, I think we could start building some eaves. Alright, so let's start by creating a base shape. Could be just the line goes from the minimum position to the maximum positions and extrude that line to create the eaves. That's a simple shape. Okay, so shall we do that? I'm gonna use a line. The direction is X direction, and to align it with the wall, I'm going to use a match size. And let's place it on the bottom. So the Y is minimum, and also scale it based on the X direction so that it fits with the wall. Okay, that's good. Now we can do some process from here. Now let's use a point wrangle. For this line, I'm going to refer to a window-sized cube as well as the wall. Okay. And I'm gonna create a baseline for the eave just above the window. Okay. So first step, I would like to get the top part, the top positions of this window box, which you can get from the bounding box information. So get B box, minimum maximum, and then let's try changing the eaves height to the maximum Y. Now you might want to have some offset from the top to from the box. So, and you don't want to go above the unit height, which is the wall height. Like this one, you don't want to go above this line, so you also need to have some restrictions for that. So let's get that information as well. I'm going to have another minimum and maximum for the wall. Okay, and I'm going to say whichever minimum is, I'm going to use that. And for the value from the window, the top of the window, I would like to add some offset value so that I can raise the height up a little bit, just like that. But if it goes above the wall, it just stops there, so the height will be restricted. Okay, so it should be in between. If the minimum is 0, it should be in between 0 to something like here, the top of the wall. Okay, so that's good. Let's set it to like something like 0.2. And next, I would like to have some angles for the extrusion. So I want to go have some like 30 degrees or 40 degrees of angle as an eave for the rain. So let's set the normal directions for that. And for that, I could use maybe a trigonometry or just a rotation matrix to rotate the x-axis. Let's go with the simple one. I'm going to create an x-axis first. No, not the x-axis, but the negative z-axis. So that's set 0, 0, -1. And I want to rotate these directions by, I don't know, 30 degrees or so. So matrix, create an identity matrix, rotate the matrix by 3 degrees using X axis as a rotation axis, and then rotate the Z axis with it and update the normal with the direction that I've just created. And let's check. Okay, we have to rotate the negative 30 direct angles. Okay, so this could be parameterized, I guess. So let's call this angle, and let's start with the 30 degrees. Okay, and to this directions I also would like to extrude. So let's also define the length, how much it should be extruded. So let's give a value called Z scale. I'm gonna set it as a depth parameter. Let's go with 0.6. Okay, everything is in meter in this case, in the logic that in the system that I'm creating. Okay, so I think I have pretty much everything I need for the base shape. Now let's use poly extrude to extrude this line to a normal direction by setting a point normal to existing and set the distance to 1, which will be multiplied by a local control Z scale to actually use the parameter that I set here as an actual length. Okay. And let's see it together with the wall shape to see the balance. Okay, I might be too deep. Something like 0.8. Maybe you could also raise up some offset. Okay. Now these values could also be randomized or fixed. Your preference. Maybe the angle might be fixed. The depth and the offset could be, I don't know, randomized. It's up to you. Okay, and let's have some thickness to this eaves as well. I'm just adding additional poly extrude to this with a small offset here, just to have some thickness. Okay, and normalize it. Create a normal. Okay, and let's also apply some group here for material that you would like to use. I mean, you should be also applying some UV as well if you want to apply textures. So I don't know, anything you like. UV texture. Yeah, we'll do it. So I mean, same for the walls as well. You think it's a good idea to set the UVs. So I'm going to just apply UV textures to this base wall here first of all, and check how it looks like. Now it's being deleted somehow. Where? Oops. I think I need to set it to Z-axis. Oh, yeah. Okay, and now, yeah, looks good. I guess for the windows and sashes is, yeah, you might still want to have UVs as well. Where should we set that? After split, I guess. After split, after slicing. Where was it? This one. After slicing, I think I should set some UVs here. Z-axis. Yeah. For just the window. Yeah. And that will be okay. Well, sashes is missing a UVs as well, so maybe in the end you also might want to have a UVs for the sashes as well. Yep. Okay, it's not really clean, but we'll do it. Okay, and you have an eaves with the UVs. And the group name, I'll just name it as eaves. Okay. Now you're curious more about complex trigonometry approach. I mean, it's not that complex, but let's see. So this is where I was on. So instead of using like matrices, you could just say set. So for the x, you can use cosine, radians, 30 degrees, maybe minus 30 degrees. And for the y, you could use sine for the 30 degrees. And for the z, you could just say 0. And that will give, okay, so this is not facing at correct directions. I think you need, so 0, where does 0 4, 2. Oh, wait a minute. So, okay, sorry, this has to go to z. This has to go to z. Yeah. So this is a negative direction. So if you say 180 degrees, you're facing an other side. And if you add 30 degrees to it, you are going clockwise direction. So this is another way to write instead of doing like this. Yeah. I mean, it's more easy. Oh, where it? This one is a bit more easy to imagine how it works. This one is a bit hard to imagine how it works. I think that's the only difference, I guess. So either way is fine. Anyway, I will. You could still do either way. Yeah, should work the same. Okay, so this is for the eaves. What else? Let's think about creating some like balconies, or could be a balcony, or could be like a washing pole, like a lavatory pole. how do you call it? Where you hang your clothes, right? Which I saw it on the photo. Like these part, I think people are hanging some clothes outside, and there seems to be some poles where you can hang some clothes or place some boards. And this one doesn't have any balconies, but yeah, we could add by ourselves. Okay, so let's think about how we could add that. Again, we do need to have a balcony. I mean, the balcony could overlap with the window, right? So yeah, let's think about it. Although the pole, the washing, the laboratory pole must be beneath the window so that it's not going to intersect. So either you have balcony or poles or nothing. That could be an option. Okay, so again we have a reference window as a reference. Let's have it on the null node. Call this window box. So that's it's more easier to refer to. I'm gonna use the object merge. And whenever I want to refer to, I am going to use this object merge. Okay. Same for the base wall, which I'm referring to it a lot of times. So each time I use this base wall, I'm going to use the object merge, just to be able to see the whole thing a bit better. Okay. And right here. And I want to use it right here as well. Okay. And we have it here as well. Okay, so what else do I need? I think this is all I need. Base wall and the window. Okay. So let's start with the balcony, shall we? So for the balcony, I would like to create some like extruded small wall at a height of your maybe from chest, the height of chest maybe, just to sum up a little bit higher, like 1 meter or 1.5 meter, and use it as a fence, and have some depths like 50 centimeters to 1 meter. Okay, so we could start by using, I don't know, maybe using the same line coming from here is possible. Right, this line could be used. So let's give another name here. Bottom line. Bring that here. And reference it here, and in this case I want to extrude it to a negative z directions and with the depths, and extrude it on y direction. So first of all, I'm going to create a normal direction for the, as a vector value, going negative z direction, so default value -1, and use that to poly extrude. And using point normal existing, and you can define how much you want to extrude. Okay. And let's also create some fence from this plane. Now you could start by creating a fence wall, and then extrude that. Maybe that's better. Yeah. Or if you want to be more specific, more detail, you first create the floor for the balcony, then create a fence next. Okay, let's create the floor. Poly extrude, another poly extrude with some thickness. 0.1, that's 10 centimeters might be looks too thick, but yeah, something around that is fine. And let's create a wall. I mean, in terms of the balcony wall, there's a lot of options to, a lot of designs. So I'm not sure what will be. I mean, the simplest is something like that, but we are working on more chaotic type of apartment. I don't want to make some clean shape like these. Balcony. Hong. Yeah, I'm looking for something like this. The simple one, or like this. Yeah, maybe. Still clean. I like it. I like this one. It's not like fences like this, or small fence like that. This is not a balcony though. Well, I am just going with a really simple one, like this one, yeah. So we have a top fence and some poles and some glasses, or just a concrete wall. Okay. So how should we do this? So for the top face, I am going to set the group, how do I say, fence. And for the other geometries, now as a base, there's how should I call it? Okay, I'm gonna decide it here. So for the back, I'm just gonna call it balcony. And for the side, I'm also going to call it as a balcony. Just for the top part, I'm going to call it a fence. Now for the top part, how should we deal with it? Let's set the normal, clean up the normal face. Okay, and I just want to have a fence shape like a C shape here. Now, the easiest way, if I just use another poly extrude with the inner inset for the fence. Now actually I don't really want to have these faces here. So that's a bit of problematic. I mean, I just want to have these faces. And I don't think I can control... Am I able to control per edge with this one? I don't know. I don't really know. I don't think so. I think it's per primitive, so... Nope, I don't think so. One thing I could think of is move this point, project to this direction. Also move this point, project it on this edge. Then delete the face right here. Maybe that's the way to go. I'll try that. Okay, so let's set the group again after the extrude, poly extrude. So let's say the thickness is okay with 0.1 for now. Going into the extrusions, the front side, I am going to call it as a balcony. The side is the fence. Okay, let's check. Let's check the color. So I'm just going to color the fence. Nope. Actually, I don't want to have this middle part to be fence. What about balcony? Which part is the balcony? Okay, so balcony is okay. The fence wise, I don't really want to have the middle part to be a balcony. I mean the fence. So, gotta fix that. I want to remove the fence group from this middle shape. Can we do that here? Maybe not. Nope. So I'll just use a group combine node to subtract group name fence is equal to fence, subtract with balcony. Okay, that should do it. Okay, so and next I am going to sort. I think what I'm doing here is not really effective. I mean, not so efficient at all. Just doing as I think, so it's not really efficient at all. But I'm just sorting these plane by z coordinates so that the first and reversed, so that the first primitive will be this plane. And let's check by deleting that fence, which is supposed to be the first one of the fence. Oops. And what I would need to do is to move this point to this directions, meaning I have to what if I can just pick up the first fence primitive and then scale the z coordinate to 0 using the 0 value as a coordinate positions scale center. I should be able to also move those points to the left hand side. So point wrangle and or maybe primitive wrangle, and just looking at the fence. Okay, and just want to look at the first fence, you know, so prims, maybe I can just say detail and expand prim group, looking for a fence, and I don't really need to apply some groups. So get all the primitives having fence group, and the first one should be this one by sorting by sorting with this z coordinate, hopefully. So I get the first one, get the point attributes, I mean prim point informations from this primitive, then move that point by scaling just z value by 0, update the point with the updated points. Okay, so looks fine, I guess. And then on the last process, I could just remove the primitive, which is currently the area is equal to 0, so you're not going to notice the change. Yeah. Okay, I guess that'll do it. All right, so let's create the fence from this edge here. Okay, so another poly extrude. And for the fence group, specify some height. Let's see the balance between the walls and eaves. Yeah, so if it's too short, people's gonna fall, so maybe more than one. I'll go with one for now. I mean, this should be parameterized as well. Okay, now let's set the group. The next step, I would like to set up some face shape. So that's the side in this case. So let's set the side as how do I call this, fence again, and for the front side I'm going to set it as balcony. Backside, we don't have a backside, so okay, let's recolor this to see how it looks like. Just going to color the fence. Okay, I don't really want to have the fence group to be applied on the top, so again we're going to use this group combine. Yeah, alright. Okay, now another poly extrude for the fence, and this time going to use a individual elements and inset, have some inset this directions. I wonder why I cannot go over this value. Wait, not sure why. Actually I don't really want to have this part to be insetted. This part should be either empty or set as balcony. Okay, well, this part is actually being attached to the wall, so I think I could just delete it. Right, so let's just delete those parts. Where can we do that? Maybe after somewhere around here. Maybe somewhere around here. The rule here is that this plane is attached to the coordinate 0 equal to 0, z equal to 0, so primitive wrangle. I could just create some simple rule here, or I'm not sure if the delete has some patterns. I don't know how to access the x coordinate of the primitive, so I'll just do it primitive wrangle. if p dot z less than 0.001, which means it's pretty close to 0, just remove that primitive. Oh, actually, you should do with the positive. Okay. Okay, so this part being deleted. Now you can go and set further. Okay, so let's call this 0.05. Right, and the front side. Okay, for the side, I'm going to name it as balcony again. Balcony, or yeah, balcony. And for the front side, let's call this fence. Okay, now I would think I need another group combine here, and let's check the color for the fence. Okay, now I can have some final extrusions to have some depths, and that's the end. I mean, this is too bulky and doesn't really look good, but anyway. So we're looking at the fence, offset to a negative directions by, I don't know, 0.05. That was too much. 0.025 or 3. And let's make it as a glass, I guess. And for the side, again, I'll make it as a balcony group. And for the front side, I am call this fence. Okay, and I guess I need another group combine. Okay, so the red part I'm gonna apply it as a glass, and the white part I'm gonna apply as something, I don't know, white. Okay, that's good. So after combining these, will look like this. And I would like to have an option go with or without balcony, and I mean there are no exit here, so you are supposed to have the full size window here from the floor if you have a balcony. So but yeah, you could just make your own logic for that. I'll just go with the impossible shape. Okay, so where were we? So let's create some switch to go with or without the balcony first of all. So without the balcony, you can just say null, empty, either empty or having balcony. And another option is to have some like a lavatory pole or washing pole, which could be extruded from the walls just underneath the window. Okay, so let's have that as an option as well. Okay, so this is a balcony. And I guess I need to apply some UV as well. So let's do that. Where shall we do it? For the UV textures, for the first of all, for the if I try face, yeah, I think this will do it. I mean, it's not really clean, but at least you could apply some textures on it. Okay, I'll just go with this. So if I have it with that balcony, it looks like this. Okay, it looks fine. Now for the washing pole, or let's think how I should create it. So just going to create a simple like pole, the horizontal pole like this. Extrude it from one of the wall, the side of the wall like this, and extrude it horizontal to this window, to the wall direction. Having like, I don't know if I can search with the right term. I'll just search with the Japanese. Yeah, something like that, something like these poles, which is being applied, fixed on the wall. Maybe, or something like these extruded from the wall, so that you can hook your poles for your laundries, clothes. How do you call this? Anyway, so let's create that kind of extrusions. Could be really simple. So in order to do that, we do need another reference, which is the window size and the wall size. So let's get those. I have a question from Ton. If it doesn't take long, can you please briefly explain or show how to color the balconies based on the pattern, such as every second balcony is black and the ones in between are white, checkered pattern? Okay, call the balcony based on the pattern. Interesting. I mean, currently a pattern's being controlled by a type right here, coming from the type here. So if you want to control based on like if you want to control the balcony color with this setup, you have to make sure that your wall pattern, which is currently randomized like this, has to be checker patterned when you create the wall type here. Okay, so that's initial things you need to do. And if you want to do that, instead of using a noise pattern, which has been applied right here, let's say let me think. So in order to do that, you need to have a height informations as well as a horizontal informations in order to achieve that kind of informations. And just like I did for the noise pattern right here, you could use the ground floor informations to get the seed, which you could reuse it for a checker pattern as well. So shall we try that? So in order to create a checker pattern, you first of all have to create a checker patterns on the ground plane as well. Okay, and I am referencing this one here. So before this pattern, I think I should create some checker patterns on the ground. And shall we do that? I think it's an interesting challenge, so let me try that. Okay, so I'm going to use a primitive wrangle here. call this checker. Okay, then I will need to know how many planes that I have on an x and y directions. Now currently the x and y has the same numbers, so it's pretty easy to determine rows and columns are the same numbers. But let's say there's a chance that these numbers are a bit different, meaning you have something like this. The rows and columns numbers are a bit different. So I'm going to consider this kind of patterns, and let's see how we're going to solve, how are we going to create a checker patterns on this kind of grid. Okay, so to be able to create a checker pattern, first I need these informations, this 50 and 70, how many divisions you have on x and z. Okay. Then let's copy this one. Let's copy and paste the rows here, paste the columns here. Okay. Now these numbers, they are primitive numbers going this way, which is a column direction. So you could specify the current column value, in this case x, by dividing the primitive number, calculate the modulus between the primitive number and the columns plus 1, I think. Let's check. So x is 0 to maximum 43, or not, maximum 70. Oh, wait a minute. 70. Why is the last one is different? Okay, this is wrong. Has to be like this. So the last one, no, it's actually -1. Okay, so that every x, the maximum is a 68. Yep, same as these value. And for the y or z, you are going to divide by the number of columns and calculate the floor, which should be in between, it should be the number related to the number of columns. If I check it, the z is, maximum is 48. Yeah, looks correct. Okay, so now that I have x and z, I could combine these two to create a checker pattern. Okay, so checker is ix plus iz and modulus 2. Let's check. Let's check it by coloring the grid by the ramp. Okay, now that I have a checker pattern like this, and so not easy to target the balcony objects and change its color based on index of balcony That way you can change the color patterns of your objects models. Yeah, you could, but you still need to apply index informations to the wall. So addition to the type, or you could include that to a type. So yeah, you still need to add some attribute information to the wall. And I'll show you how you can do that. So we have a checker pattern here, and now we are referencing that right here when we are creating a wall type. Addition to the wall type, I could apply a checker informations to each of the wall based on these informations here. So let's do that. So we can first of all retrieve the checker pattern from the second input as a reference on the floor. Okay, and then based on the height, based on the level of each wall. So do we have that information somewhere? We do have a point height, but yeah, let's use the point height then. The height is we do need the unit height information, so which is 3 meters. Right here. And the height integer, meaning the level, is the current height and divided by the unit height and floored will give you the level starting from 0, I think. Yeah, and then the final checker pattern is checker plus height modulus 2. And let's try applying that to a wall. See how it looks like. And so instead of primitive, okay, forget about the ground, but for the wall looks like a checker pattern. Now then we can, apply this checker informations to a balcony color. Okay, so if we are okay to just go with the same balcony for now, and the final will be looking like this. And if we want to change the color of the balcony based on the checker pattern, then we could do that we could do that on the last node after the loop. Let's say I want to change this blue color based on the checker pattern. We could say, I don't know, maybe, you could still use color node for the fence, was it the name? Primitive, and ramp from, wait a minute, I think I also need to transfer the attribute checker to the fence when we were copying the primitive, when we are copying this one. So I'm going to copy one attributes from apply to primitive, copying checker. Do we have a checker? Nope. that is because I have to bring the checker to the point first of all. Okay, then checker, okay, there you go. And then we can go here and use a ramp from attribute checker and go with any colors you want. And there you go. I don't know if that's the case you're looking for. Okay, so yeah, that's one way to do it. Okay, well, going back to where I was, I was trying to switch between no balcony or with balcony or a lavatory pole or washing pole or laundry pole. Okay, so so we have a wall. And we have a window box here. And we would like to have some poles coming out of the wall. Should be pretty easy. Now, let's bring up another bottom line here. It's pretty feasible. And sorry. And let's decide the position and the size of this pole here. So create the bottom line and apply that, connect the bottom line to the point angle, reference to a wall. And then window box to the third input. Okay. Now, okay, so first of all, let's offset this line a little bit smaller, shorten this smaller, shorten this a little bit smaller, and by setting some, could be a length, could be a scale value, not sure, but let's call this length, shall we? From the side, so offset size from the side, and to use it with the actual size you need to get the current wall size as well, so get B box size from the second input. Okay, now the actual scale for X direction is, wait a minute, size dot X minus offset multiply by 2. So that's the goal size, and the original size is size dot X. Okay, so that's for the scale, and if I scale the X coordinate with this scale factor, should be able to control the lengths based on the margin lengths. Okay. Alright, so let's bring this above the bottom floor and should go beneath this window box, so which should be in between 0 to the maximum height at the bottom height of this window. And I think the initial position could start from the bottom of the window, then calculate how much f should offset downward, just like I did for the eaves. Okay, so let's get the bounding box information from the window box. Get B box, get be box. Okay, and the base y coordinate will be minimum dot y. Okay, so it's gonna be attached to the bottom of the window. Then I want to have some y offset to this. So minus some y offset value. And it should not go beyond, it should not go below the floor, right? So previously we were using minimum, but in this case we're going to use maximum 0. The floor height is 0. Okay. Now, if we do this, we're gonna be able to control the height position of the pole. Now, what I'm gonna do next is to create or divide this line using maybe some sampling function or sampling node. Define how many divisions I have, like 3, 2, 4, I don't know. Let's go with 3 divisions, 3 points, and I'm just going to place those, how do I call it, the hook from the wall to this position. I'm just going to create a simple hook, like made of box. I don't know. Box is not really interesting, but I'll just go with this for now. Let's not go too detail. You could always add the detail later. Better to start off with a really simple shape, I think. So let me think about the scale. So 20 centimeters is, I think, is enough. Yeah, and in terms of the height, 10 centimeters, maybe a bit too. 10 centimeters, yeah, might be okay. And thickness to 25 millimeters. Okay, so let's go with these. Not so pretty, but anyway. And I would like to, let's place it here and check it with other geometries. Okay, so I want to place the end of this box to the point position of this line, polyline. So I have to move the pivot position. I am going to use a match size again for this box so that this edge comes to 0. And that is the maximum. Yeah. Okay, for X and Z, I'm just ignore it. Okay, now I could copy 2 points. Just like that. Now, maybe I might want to round this part just to make sure that it looks like a hook. Doesn't really look like a hook, or maybe I can just make some like a circular hole where you can put a pole to it. Maybe that's enough for testing. Okay, so let's create a hole as well to this box. After changing its positions, I am also going to create a hole with the boolean. I'm gonna create a cube geometry, closed it, x-axis, make it small enough, 0.25, maybe 0.2, and the length was 0.2 on x direction. The length was 0.2 on the x direction, so I'll copy this, paste it on the z, okay, plus the radius, maybe multiply by 3. Okay, and let's increase the radius a little bit more. Okay, I think I should make it 2. Yeah, around this. Maybe I'll just set the fixed amount of offset, like, oops, 0.1. That was too big. That was too big. Okay, you can see that I'm so bad at the modeling, but yeah. And do a boolean. Okay, well. Let's just go with this, and let's also create a pole. We might also have some options whether we have a pole or not. Let's create a pole from this line. So we can just transform it with the same directions that I moved here. So I'm gonna copy this parameter, paste it here on the z value. Okay, and using poly wire to create a pole, and maybe I should also extend the size a little bit to the x direction, so I'm gonna multiply x coordinate by 1.2. Set the divisions to 6, and the radius is, I could just copy this one here for a wire radius. And let's see how it looked like when I combine these two together. Okay, the pipe is a bit too big, so let's multiply by 0.5. Now that is a bit too big still. Well, it's 0.4. Okay. Alright. Now it does not really look like a washing pole, but anyway. Okay, and that's good. Let's create some group to each of the objects. For the pipes, let's call this pole. For this, how do you call this? I don't know, joint. And the joint needs a UV as well, so let's give some UV informations, probably just to a box. With maybe face. Yeah. Okay. Okay, so looks like this. Pretty simple. Okay, so we have 3 options. No balcony, with balcony, or with the washing pole. And let's create some values to choose between these 3. I think we should also be able to control the ratio of having none or fence, the balconies or a washing pole. Okay, so going back to a wall pattern, let's create another parameters. How do I call this? balcony options, or I don't know, not a good naming, but anyway, and it's either 0, 1 or 2. Alright, and let's copy this parameter, paste it here so that we could parametrically choose between none, balcony, and washing pole. Okay, and this is where we want to decide using a type parameter, just like we did for other random values. So first thing first, let's create a random value. Just like we did here, which is in between 0 to 1, and just give some random seed additional value. Now, since we have 3 options, 0, 1 or 2, and we need to do something related to these threshold comparison, like how many percentage of the wall should have balcony, how many percentage of the wall should have nothing, how many wall should have washing pole, and so on. Okay, so in that case we need 2 values, percentage for the balcony, percentage for the pole, and rest it will be nothing. Okay, so I'll just call it balcony chance, and washing pole chance. Okay, so let's say 60% of times you have balcony, 0.6, and 30%, maybe 50% you have a chance to have a balcony, 30% of chance you have a chance to have a washing pole, and the rest, 20%, will be nothing. So if balcony options is less than balcony chance, the integer balcony options is equal to 1, else if balcony options is less than the balcony chance plus washing pole chance, the balcony options is equal to 2, else, and these part, everything I did here is random, but you always can implement your own logic, so that will create more interesting result, I think. 0. Alright, and then we have this attribute being created. Let's just read that right here. wall info. Okay, and let's check the final result. So it is still checkered colored, but there at 50% of the times it becomes balcony. And what's funny is that balcony still appears when there is no window. So maybe you might want to change that. At least you should have a window, right? If you have a balcony. This is not optimal. So if you want to add that kind of logics, you might want to do it right here. So you already have a no window options here, right? So if this is true, if this is equal to 1, then you should skip using balcony, right? So let's say and no window is equal to 0. Then you can avoid having balcony for no window wall. Maybe you should also avoid having poles as well. So like that. Okay. So if there are, and maybe you should have some options to control whether you could have Eve as well, right? Because there's no way you need a weave for Eve or wall without the window. I think there's too many walls that has no window, so let's reduce that to 0.05 or less 0.02. Yeah. Okay, let's go back to have some options to choose whether you could have a Eve or not. And after that I'm going to create the rooftop and also the ground and probably finish it, since I'm already doing this for 4 hours. But I think I'm being able to show the base logic how this works, at least. Where were we? So this Eve is this one, right? Okay, so let's have an option for a switch to go with an empty shape or with the Eve. Okay, and then create additional parameters with Eve. Okay, from 0 to 1. Copy this, paste it here, and then going back to the parameters and let's create another value having Eve or not Eve. Okay, so let's have it somewhere around here. So another random numbers. I mean, for this one, let's say if you have a window, you always have Eve, and if you don't have a window, then you don't have a Eve. And I think that makes more sense. Okay, so in that case, you can just say if no window equal to 0, then you always have the weave, right? I think that should be the condition. Okay, and then let's read that info right here. wall info 0. Okay, and let's check. So if there is a window, you do have a eave. If you don't have a window, if it's just a wall, where is it? Where is the okay, let's increase the no window ratio a little bit more. Let's call this 0.7. Okay, so if there are no window, nothing shows up. That's fine. Okay, looks good. Now there could be several more things you could do for the walls, but for now I'm going to create the rooftop next, which is pretty simple. After the split, you have both ground and the rooftop. So let's just pick the rooftop part. I'm gonna split it into 2 again. Just gonna pick the rooftop shape. Then I'm going to use a poly extrude. And first of all, I need to create the fence or parapet, so-called parapet. So let's create an inner inset extrusions first of all, like that, with maybe 0.2 is okay, 0.2 or 0.3. I think it should be thick enough, so 0.3, 30 centimeters. Okay, and then extrude those faces. So let's name it to the front side. I'm going to name it as rooftop, and for the side I'm going to name it as a parapet. Okay, now again using poly extrude, I'm gonna pick the parapet group and extrude it to the normal direction with enough height, like I guess 1 meter is fine. Then yeah, that's pretty much it for the rooftop. It's pretty simple. And after that, I'll just set the group to rooftop and the side as well, a rooftop. Okay, so that's pretty simple. Let's combine these together. When it comes to more complex shape for the roof, I think it will be more difficult. The height of the rooftop is offsetting. I think I know a problem. I think I know an issue here. That is because this wall pattern is placed on the ground, but initially it started from the middle. I mean, the center of this shape has been placed on the center, the 000, so I have to replace it to the center in terms of the y coordinates. So I have to use a match size again here, just moving the y to the center and everything else stay the same. Yeah, just like that. Okay, so with this, I think it should fix it. Yeah. Now let's add some UVs as well. How did I add the UV for the wall? I think it should be continuous at least. Let's just try using UV texture to see how it looks like for the face. Doesn't really look good. Nope. Does not look good. Okay. So the wall has been created using one plane, but each one of the faces that I've created here is created differently, so that's a bit problematic. Well, I could go back to the wall pattern. Instead of using orthographic UV, I could use face here. Might fix, okay. So this could fix the issue. I mean, just assuming that you're using a repeated pattern, but there is a issue right here. There's a seam here. Okay, so that's not good. That is not good. Let me check what's happening here. Okay, so the face, fixed boundary seams, no. So it's much better with this way. Yeah. And I am not sure what's the best one. I mean, you could also apply UVs customly. You could always do that, but it's a lot of hassle here. After you have done a UV here, can I place it here? It's pretty much the same. Thing is, you cannot use orthographic here because it's everything combined. Alright. Well, what else do we have? UV textures, UV unwrap, UV project. Nope, I don't think it works. UV quick shade. Nope. I mean, it's not really clean, but you could always go to here and change the scale, which might not be a good idea. Yeah, it's not a good idea. I don't think it's a good idea at all. You should also make this parametric for sure. So, what's the best way? I don't know. Since the way it's been created is different, so if you want to make it seamless, I guess you have to copy the setup from the walls to these places, or you could separately replace the face here, just like I did with the wall. Yeah, maybe that should be the way. I don't know. Or you could just recreate the UV for the walls right here, and that will make the continuous UV for everything. I am not sure if that's the good thing to do. Maybe not, I don't know. Well, let's just go with this for now, shall we? And set the color of the rooftop to white. Okay. What else? So the ground floor should have some different facilities, just like you see it here. This could be a shopping areas, or parking lot, or where people can walk around, like piazza. So let's create a ground floor a bit different to what we have here as a repeated pattern. Okay. Labs auto UV usually does a trick, or maybe continue the top walls and make a rooftop by insert, extruding cap. Okay, I think that's a good idea. I didn't know about the labs auto UV labs. Let me try. But it gives you kind of a diagonal UV. If I do that here, oops, might have been really really heavy. So I guess it is assuming the seam for each faces, I guess, and yeah, it using auto seams. Okay, takes too much time. I should have filtered by the group. Okay, let me just delete it. I'll come back later. Okay, so the ground floor, and somehow my camera is tilting. Funny. It always happens in my Macintosh. I don't know why. When I use space key and F, it just rotates with the row. I don't know why, and I don't like it. Okay, so ground floor. So let's start with the ground plane, which is this one. It's being trimmed. So we could reuse this one or not. We could go back to where when it's not being extruded yet. Okay, this one. So we just need this red part. So let's bring up the initial grid. To create the floor plan, the first ground plan. Object merge, initial grid. Okay, and let's just get the red part, shall we? So let's delete it. The rest of the part. Okay, then let's see what we could do. So from this image, I'm seeing the eaves, the bigger eaves, maybe for the shopping place or shopping areas. So I'll just mimic this kind of pattern, create the eaves just bottom of the apartment unit, then create some open space inside, and that's pretty much it. Okay, so to create the eaves, in this case we have a square shape eaves and a bit more complex eaves shapes somewhere around here. So what I am going to do, first of all, I'm going to create just going to delete the inner edges first of all by using divide node. Then I'm going to use a poly expand to D to expand the edges using offset surface just to the outside. Define how much you want to move. Like 1 is 1 meter, so it's pretty big. Let's go with the 1 meter, shall we? Okay, and we want to have some angles to these eaves. And we could do that by applying an edge distance as an attribute, a vertex attributes. After the poly expand 2D, you will see these edge distance on each vertices, which is a value how much it's been moved from initial point position. So we can use that as we can use that to create a how do I say a gradient. So I'm gonna use a point wrangle. Access to that access to this edge distance on a vertex. So to do that, we need a vertex numbers from the point. So point vertex, get the edge distance. What was that edge distance? Okay, get the edge distance from the vertex. And then move the point to y direction by minus edge distance, which will give you a 45 degrees angle for as a gradient of the eve, moving x and y in the same speed. And like that. Okay, and if you want to control this gradient, you could multiply this height by gradient threshold or multiplication. So goes on x directions by 1 as a speed, and if you say 1 to the y directions, the same speed has been applied, so 45 degrees. If it's 0.5, then that's maybe, I don't know what's the exact angle, but a less angled curve and so on. I'll just go with 145 degrees. Okay, and that's good for the base. Let's have some thickness. So let's create a poly. Before doing that, let's give some UVs to this. Again, I'm going to use a UV texture with the face. Okay. Then poly extrude to have some thickness. And let's give some thickness like 0.1. That maybe that's too big. 0.05, like 5 centimeters is still really thick. 0.02. Okay. And let's also create a backside as well. Alright. Now let's also create some poles for this eaves. Maybe I can just place some poles based on these divided lines. That's the easiest place I could think of. So going back to where I had moved the eaves, and let's pick those points. How do we do that? That's the easiest way to do that. Now we do have this information this way. Okay, so just going to merge this eave shape as well as the ground floor plane, fuse it, and delete the inner edges by dividing using divide node plus remove shared edges, and you're left out with the outline. Now if you check the point in positions, it looks like this, and this is where I can put some poles, but I might want to have some offset inward, so let's create poly extrude and extrude it in inset direction like that, maybe like 20% inward, and I don't need a side geometry, so I can check off this geometry so that I'm left out with these points where I could put the poles for the eaves. Okay, now let's create a line for the pole which defines the height. So I could go to a unit height. I mean, ground floor could be higher than the other units, right? Normally it's higher. If the unit height is 3 meters, then it could be 4 to 5. So I'll just copy the lengths here, plus the eaves height is equal to 1, so the total height will be 4 meters. So I think that's good. That sounds good. So I have the line here. Let's create a polywire. With some divisions. Let's make it reduced. And the pole radius 0.1 sounds okay. Okay, now I am going to copy this copy this pole to each of the point right here. I want to make sure that the top part of the pole comes to this point. So I have to move the top part of this pole to origin in order to do that. So I'm going to use a match size again, match size, and just move the Y to maximum. Other one, keep it to the original. Now I could then use a copy to point to move the pole to each of the point on the eaves. Now, okay, so the direction has been changed. I don't want to change the direction, so attribute create. I'm going to make sure that the up vector for each point is 0, 1, 0. Oops. also the normal. We need to have a normal as well. For as a vector value, I'll just say x cool. Okay. And that should fix the coordinate, the orientation of the poles. Now I think I should be able to merge the actual eaves and the poles together. Just like that. Now the pole looks a bit too thick. Proportionally, it looks a bit too thick. Let's make it smaller. Okay. Now let's try adding together with the building. And right now I think I can just add it here. And well, I guess it has to have something inside as well. I mean, you cannot just make it open space like this. But yeah, seeing from far away, it looks like this. It looks starting to look like a jellyfish. Hey. Okay. Now let's finalize the ground floor by creating a inner wall. Could be just a wall coming from the top wall. So yeah, that's the easiest way to do that. So to do that, I can go back to where I have this one and extrude it until the bottom of this line, the bottom of this pole. Okay, so shall we do that? Okay. Poly extrude. And create the distance in this direction. Maybe I should make it reversed. I don't need a back face. I mean the front face, I just need a side. And in order to determine the distance, I think I could just apply a local z scale estimated from this line positions. So I'm going to create the primitive triangle referencing to this points, I mean the poles. Then get the minimum positions of the pole collections, and I'll just set the z scale as the absolute value of min dot x by y. So as a result, z scale, wait a minute, let me check the value here. The z scale at 0. Okay, that sounds wrong because I have to look for the second input. Okay, so now it's 4. Sounds correct. Okay, looks correct. And now I can add this wall here. And looks like good. Looks good. Now let's set some groups here. So this is wall. And what else do we have as a group here? This is just a wall. Building has been deleted, so that's fine. For the eaves, this is for the ground pole, and this is for a ground eve. Okay. So that seems like an end. And let's recolor all the stuff based on the group to see if I have the correct grouping for each object. So let's start with the wall. Wall. I am going to use like green. Maybe I could use the same group for the rooftop, maybe. Okay, so walls and rooftop looks good. Next, a ground, eve. Okay, blue. So that looks correct. For the ground pole. Okay, magenta looks fine. And the eve. Okay, how does this eaves, I guess. Oh yeah. So eaves looks fine. Okay. Balcony. Okay, so it's changing the edges. Okay, fine. For this fences, it's changing already, so that's fine. For the window, yeah, it's changing. Sash. Sashes to, okay, it's changing. And these one, how did I call it? Forgot. Pole, sash, pole, okay. Pole, it's fine. And finally the joint. What else? Is that all? I guess so. Okay, the color doesn't really look good at all, but at least the grouping went okay. Okay. Now the ground floor, maybe you could do a little bit more with these details. I won't go too much for that. I'm just going to add some ground floor road or street addition to this, and I'll finish this setup. So going back to the floor plan. This is the rest of the floor, and right now it's been going down a little bit. I mean, the the z equal to 0 positions is right here, but actually the bottom of the floor is right here. So I need to raise this up a little bit upward. So I should use another match size before creating the road. Justify y to minimum and rest set it to none. Okay. And then you should be able to add it together with the ground. Okay. Now for the ground part, I don't know. I mean, you could use some other logics to apply some road or parks or piazzas or something like that. Let's just give some one grid offset and use it as a road for this apartment complex. So checking out this one, what I want to do is to have a outline grid. Just pick those lines just outside the building and use it as a road. Okay, so in order to do that, let's see how we could do that easily. Well, we do have initial grid here. Okay, let me move this a little bit. Let's see what's the easiest way to do. I mean, I think I can use this base building shape to get just the outer grid faces. So I could still use this one as a reference. Let's give a name. Let's bring this up, and then I'm going to offset or give a little bit of offset from the outline outward by using polyexpand 2D. Just a little bit, using toward the outside using the offset curve and offset by, I don't know, 1 meter. Okay, which should be more than the half size of the width of the grid, which was 1, so maybe 1.1. Or to make it more procedural, oh, there was 2.3, so I should be more than half size of this one. So I can just say 2.3 multiplied by 0.75. Okay, that should be good enough, big enough. And then I can now check for the grid which is overlaying with this grid expanded geometry. Okay, so let's test it out. Primitive wrangle. Oh. Check the distance between the grid center and the expanded 2D geometry. Oops. Distance, XYZ distance. If the distance is small enough, that's good to go. If it's more than 0, you don't really need it, so remove prim, or maybe I'll just set the group. So if it's close to 0, set prim group. How do I call this? Pedestrian road. If not, just say ground. Okay, now let's check it. Color the pedestrian grid. Pedestrian with green. Okay, then the rest with the ground with a bit darker color. Okay, now let's see how it looks like with everything connected. And if you want to increase the amount right here, you could always go back to a polyexpand 2D and increase these numbers. So if you want to have two expanded grid, then this value should be 1.75. Yeah. This looks better. The color is too bright, but I mean, if you replace it with the texture, it should be fine. And to do that, you do need a text UV as well for these grounds. So let's create that somewhere. You should go back to here to create the UV, I guess. No, this is fine. It's fine, or you could use face. Yeah, whichever you like. Okay. Looking good. Yeah, and one thing I want to add to this setup is a AC box, air condition box to the window, which I saw a lot on like apartment building like these, like in Hong Kong or any other countries. So let's do that as a final touch. Okay, so the rule for the position of the AC, if I look at these images carefully, it's kind of placed center of the window slices or window parts most of the time. And so that's what I would like to try to do as a simple rule. Pick one of the slices from the window and place the AC maybe from the edge of the slices. Okay, could be here, could be here, could be here, could be here, and so on. And based on the types, it could be randomized. The position could be randomized. Alright, so let's do that as a final touch, and I'll finish this live. Yep. And in the end, I think I'm also going to try to make this layer a bit more bigger with more plan-wise detail. Plan-wise what? Noise. Okay, so wall pattern. Let's create an AC, which should be using a window slices as a reference, so it should be somewhere around here. And this is the window slice. Alright, so let's use these information. Going to just get the window part, and based on some informations coming from the other coming from this parameter, the above parameter, let's just what kind of value should I have here? Now this is pretty much randomish, so I'll just let's just say I'm going to retrieve a value in between 0 to 1 as a float numbers and use that to determine which which parts is going to be used. Okay, so let's create a base shape for the AC. I'm just gonna make it pretty simple, just to create a box with the size. What's the size of the AC? I don't know, 60 centimeters wide, 50 centimeters tall, or maybe it's a square. 60, 60, and 40. I don't know. I don't exactly know the exact size, but let's just go with this for now. And let's create a little detail, small detail. Like if I look carefully here, I do see some inner offset. There should be some grills here. It's too small to check, but yeah. It's a box-like shape, and you do have some inner, like, I think it's a grill shape. So let's create that one. Not to make it too detailed. So let's check the face numbers here. So okay, so 0 is facing here, so that sounds good. I'm gonna use a face number 0 for poly extrude. So 0, create an inset. Name the group to the front. AC inner. Okay. For the side, I'm not gonna set anything for now. And then I'm going to use AC inner to extrude inward. Yeah, and I'll just say that this is a AC unit. Doesn't really look like so, but oh well. We're just testing. Okay. So good enough. Front AC inner. The side is okay. So now I'm also going to apply a new group to this one, which is called AC. And also let's check the color. AC color. Primitive. AC inner. Okay, so I'm going to use a group combine to subtract AC with the AC inner, so that the AC group will just be surrounding areas. Okay, well, that's good enough for now. And let's check, going back to this one and see where we can place this as a geometry. Okay, so I think it makes sense to have the corner of the AC to be attached in one of the corner of the grid. Maybe this here, 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 or here, or here. Okay, the corner, and placed within the window. Okay, if you just choose the center, it will be placed right here if you choose this grid. And that doesn't really look good. You think in reality you might want to move somewhere on the edge. Right here or right here. right here. Okay, so first thing first, let's randomly choose, or using some parameters to choose which grid to be picked. And those sliced geometry has to be big enough, I think. If it's too small in terms of the width or height, might not be preferable for the positions of this AC, maybe? I don't know. Or maybe we could just try with everything. So first thing first, I am going to use a primitive wrangle and pick the grid. So I am going to assume that I'm going to retrieve a parameter value called AC pick, which is a float number between 0 to 1. Based on those values, I'm going to decide which primitive is going to be chosen to place AC. Okay, by just normalizing the point number, I think, or converting this into a index number. So an index of the primitive could be AC pick multiplied by number of primitives floor. And I also have to make sure that the minimum is in primitives -1. Okay. Okay, now if the primitive number is not equal to index, then I'll just remove that. So you can choose one of the primitive using this value, and you can decide what value would that be out from outside. Okay, so now that I have these numbers, then I am going to choose in which positions that I'm going to place this AC. Okay, so I'm going to use a point wrangle, and let's just say it's not really a perfect solution, but I'm just going to pick the minimum point positions of the AC and also get the minimum point position of the pick grid, and then place the AC to that positions. Okay, let's try that. And to do that, I think I also need to change this pivot position of this AC. So let's use a match size to move the X, Y, and Z to minimum, minimum, and minimum. Okay, like that. Okay, then check the minimum and maximum from the second input. Then create a moving vector value from the minimum point position minus 0, 0, 0, so you don't really need to do anything. And I'm just going to move this point to that direction. Okay, which will be placed somewhere around here. Now let's see how it will look like together with the, okay, it's backside. I have to place it backside. Okay. Let's transform it to rotate 180 degrees, 180 degrees. Okay. And if I check it, and which grid has been picked? Okay, so I think the pivot has been changed, so I think I need to use a maximum instead for the x coordinate. So that will be max.x min.y min.z. Okay, and I have all. Okay, so let's see. Okay, well, okay, so it's not perfect. It's always using the minimum right here. So if it's going over, there's a chance that it's going over the window boundary. So I think I need to limit the area that I can move around. Okay, so let's give the limitations. I need to get the current bounding box information for the AC. Okay, so, and let's say this is the preferable positions, but I need to kind of a limit clamp, I guess, the positions where I can set. So the minimum wise, this is fine, I think. Now for the x coordinate, I have to look for the. Okay, I think instead of the minimum maximum, I think I need to get the size of the original geometry. So get box size, and then let's say, let's call this clamp or minimum max x or max x. I mean, is there any chance? Okay, max x and min dot y plus ss size dot x. Should I use max? And if I change this to, okay, so it's being offsetted in x coordinate, so that's fine for the x. Oh, nope. I have a problem here. Okay. It's getting a little bit confusing here, so let's go with minimum instead. Everything minimum starts with the minimum. That's more easier to think. So after I have rotated, I'm gonna move this with minimum, minimum, minimum. Okay. For the z, I'll make this maximum. Yeah. Okay, so this is a bit easier to think. Then let's get this to, so that I can just use minimum here. Alright, then I will, so now I can limit the x coordinate, y coordinate based on the size of the AC. Right, so let's do that. Okay, so for the x, that should be minimum between the minimum x and a max x minus s size dot x, isn't it? Wait a minute. Maybe not. Wait, you do need to consider the current point positions, which is wait, minimum x. So this is, wait, getting a bit confused. Let's start again. So minimum x, and the one that I have an error is this one, right? So in this case I have to offset a little bit here, and that is because if you use this one, if you use this one, okay, if you use this one, then the difference between the maximum x and minimum x here is smaller than the s size. So that's the problem, but okay. The thing is, I don't have any information about the whole window here. I'm just getting this grid info, so I should have a whole window shape info, which is this one. Okay, in order to kind of limit where I can go. Would you want to scale the AC based on the window width? Yeah, I think I could do that. I just wanted to use the same size. That's because of the, I guess, the reality issues. I mean, you might want to use the same size all over the places to look a bit more realistic, I guess, because the window size here is pretty randomish. I mean, in reality, it might make sense to see a AC size in the size of the window, but just want to try it out. Okay, so where was I? I do need additional informations from the whole window setup. Okay. Now, let's check. So, so this is Tmax. Tmin is the kind of a limit where you can go. So I think I can use that information with these info here. So in this case, minimum is going too far, so I could reduce the value by subtracting a tmax.x minus ssize.x. Okay, and let's check. Okay, that's good for x coordinate, so let's try with dy. Currently it's not within the window, so let's do the similar stuff. So for the min y, again, you're gonna use the minimum limitation t max dot y minus s size dot y. Okay, now I think I can limit the position within the window whatever I choose. Yep, looks good. Okay, now that looks fine. Let's set the UV as well. I'll just set this here. Oh, maybe I should set it before I move it. Yeah. Okay, now that sounds good. And gets placement. Now, so the parameter is this one, the value in between 0 to 1. So let's have that for this subnet parameter. How do I call this? Okay, and also I do need an option whether I should have the AC or not, I guess. If you have a window, maybe you could always. If not, you should avoid using it. So the name, I'll just call this AC pause, which is in between 0 to 1. Copy this parameter, go inside, paste it here. Also, I should avoid creating AC if the window is not being created, which is where this one, no window. Okay, so I think I could just use the same switch with the same expression here. And if there's a window, you could have an AC. If not, you could have no. Alright, so that should work. And now I can randomize this value by the type. Where I can set it somewhere here. So additional random value. Okay, and I'll just set it as FAC pause. Get that information as an expression here. And you'll be able to get randomly positioned AC box all over the places. Now, maybe too big. Looks a bit too big to me. And I think I could also have some options to avoid having an AC as well, customly. Currently every window has AC box, but maybe I can avoid having every window to have an AC box. So to do that, I could make this parameter to be controllable as well. Okay, so just like other parameters, I should have another parameter, an integer, has AC 0 or 1. Let's copy this. Paste it here. Okay, then I can go back to a randomness value, creating another value here. So let's copy this one, has AC. Now this one, you should also include the conditions like no window. If there is a window, then you should be creating. If not, you should not to create it. So let's copy this, and let's say just add some random values, and let's say you have some chance to create a AC, and at the same time you should also have these conditions. Okay, so you have a conditions like this, as well as no windows equal to 0, and when the both condition met, then you could create AC. So in this case, let's say 50%, and then let's call this integer, and let's create a has AC value, and then check for this value right here. Alright. Oh, something is wrong here. You shouldn't have this one. So what am I doing wrong? I wonder why. So you're looking at the has AC, right? So that's fine. And has AC has this condition, right? So no window is... I am having this condition, so why am I still having... If I remove it... Okay, okay, so it's only created on the no window. Wait, no, if no window is equal to 0, meaning you do have a window, isn't it? And in that case, has AC has to be 1. When it's 1, okay, the order of the switching was wrong. When it's 1, it's empty, so I should reorder it like this. Okay, so this should do it. Yeah. Now I can re-add the conditions that I had like this. Okay, so 50% chance you do have an AC on the window. And yeah. Now that looks good. Okay. Now, enough with the patterns. As a final step, or as a final tryout, I am just going to create a bit more complex floor plan rather than this. So going back to where I was creating a wall type, wall group, I'm going to create a bit more complex shape to this. Okay, what I'm gonna do is just a simple recursion, I guess. Let's use for each number, and then should I use it? Maybe. Okay, then I'm going to connect this here, and I'm going to set the value to fetch feedback and fetch feedback. Okay. And what I'm going to do, pretty much the similar stuff. I think I should create this one here. And what I am going to do here now, create the scatter node. And apply some random p scale. That's fine. And do the similar stuff here. Now, instead of using attribute create or attribute randomize, I'm going to make this one by one, and instead of using this, I am going to use point wrangle to control the p scale based on the current iterations. So let's say I have 3 iterations. Based on the current iterations, I'm going to set current p scale, starting with the big numbers and make it smaller in the end for more detail. And normalize the iterations values. Okay, so we have 0 to 1 value based on the iteration number for the loop. And based on these values, I'm going to set a p scale. Okay, so anyway, I have to start by creating random values. Using random functions based on what? Based on point position, I guess. Random point position plus some iterations. That should be enough. And what I want to do is to fit this, remap this value in between 0 to 1 based on this t value. So starting minimum scale. Starting maximum scale. Ending minimum scale. And then maximum scale. So I want to use these 4 values to determine what will be the next value. Okay, so and each loop I would like to so you could first of all estimate the current minimum scale and maximum scale by lerping smin scale and emin scale using t. Do the same for the current maximum scale. And then use it inside the fit function like this. Then just apply that to each of the point. And this could go logarithmic scale maybe, but let's just try with the linear scaling. So for initial state, let's start with 20 by 40, and in the end let's make it 5 to 10. Alright, then I might also want to change the number of points, these points as well, based on the iterations. So let's do that. So currently I'm just using initial point number, but what's the easiest way to change this? I can use the expression maybe. yeah, let's just use expression. So fit a for each count iteration, which is in between 0 to number of iterations. Oh, that's gonna be a really long expression. 8 number iterations. And what I want to do is to convert this into some values, like starting with really low numbers and end up with really high numbers. Yeah. And this should be -1. Okay. So, and why am I having errors here? Okay, not here. Okay. Okay, so let's check. So I'm just recursively creating a grid, and that might be too small. And let's increase the range from 0 to 100. And for the scatter node, I'm going to turn off the relax iterations, which could be more fun. For the initial scale, could be bigger, and I think this could be merged. Yeah. So okay, this will recursively add more details over the loop. More loops you have, more details you get. Maybe, but 3 is enough, I guess. And I also need a slider for these values, I guess. Okay, so I should have some additional sliders for these numbers. But as you can see, you are going to have more, like, how do I say, a back and forth, the push and pulls. And so instead of having these simple squares, I could just connect these here. And maybe not here, but right here. Okay, that was too big. That has been too big. Yeah, something like that. So let's be able to control those values instead of using init the point number, which is here. Instead of having that, let's update some of the parameters based on these feedback loop. So first of all, you have a feedback iterations for the ground floor, and you have a minimum and maximum number, which is currently set to 4 and 60. So start PT number and PT number. both could be a number of points, so it could be really large. 200. Let's delete this. Okay, and then we can keep the initial PTC, that's fine. And P scale, we have a bunch of other parameters, so let's bring these up. S mean scale, S max scale, E mean scale, E max scale. Let's change the name to start mean scale. Start mean scale, start mean scale, and mean scale, and mean scale, and max scale, and max scale. Okay, and we don't need this initial min scale anymore. Okay, apply, and let's also add the global seed. I'm going to add an iterations value for the loop just in case. Alright, it sounds like looks good. Now let's try. So feedback iterations, starting with small scale. Okay, forgot to use this. Paste it. Oops. It's getting too long here. Paste relative reference. Let's also copy this one. Copy parameter. Paste relative reference. Alright. Okay, now it's a bit hard to imagine what's gonna be a better value for each one, but let's just assume. So we have more points. I think I could increase the number of points and start the scale a bit smaller to have more islands. Yeah, and this will add more details over the places, and maybe I still might want to have some relaxed iterations a little bit. Yeah, this itself doesn't really look good, but let's look at the final result. And not that bad, I guess. I think I also want to control the height, like the maximum height. Do we have that? Oh yeah, maximum levels, we do have that. Okay, and we could always increase the number of grid here. Let's say the maximum 500. Let's start with 300. Now made it more like an island. But then we can now increase the initial point numbers, initial point scale. Yeah, I think I could have more points. And the speed is decent, having all those geometries, and I think it'll be more faster by packing the pattern here. The color is gone, but that's because I'm coloring right here. But the speed wise, it's going to be faster, I think. And then we could test it. All sorts of stuff. Yeah, and that's pretty much it, I guess. So if everything is connected, it shares the same height, so maybe you might want to have a bit more island over the places, some mega structures. And you also have those holes. Yeah, that's it. So, I hope you liked it. This is it for today. Let me know if you have any feedbacks, comments, or anything. Be great to hear. If not, I'll just finish this live and go to sleep. Okay, well, as always, I am going to upload the file, and you can come back to this video description page of this YouTube live in order to check the file. So that you can download and try it out yourself. And yeah, I'm also doing Patreon, so if you're willing to donate, that would also be great. But that's pretty much it. So thank you for watching, and let me just check the comments. Thank you for being here. Flexible and very easy to understand setup for apartment creation, solid techniques and form. Nice add-on might be to have an inset for some of the building with rising level. Nice idea. Well, thank you very much everyone for all the feedbacks. I think I'm getting a little bit tired doing this for 5.5 hours, so I'll finish this live stream. I will upload the files, and I hope you download it and try it out yourself. Okay, hopefully you'd enjoyed. Okay, so that's it. Let me just organize a little bit, and I am going to finish this live. Okay. Let me check. So I just want to check if I have all the parameters. Actually, I do have these parameters, so let's just promote these into a controller, and I'll finish this live. Okay. Thank you everybody for joining. Okay, I'm just gonna copy paste these one. So I have a seed value. It's already been copy. And we have a slices, informations, each number of slices. It's a lot of values. Minimum, maximum window height 1, minimum height 2, minimum window offset, maximum window offset, no window ratio, balcony chance, washing pole chance, has AC chance. Okay. My naming is so bad. What else? I guess that's pretty much it. Anything else? Yeah. When you do a pack, you cannot use the UV textures anymore, so maybe you should do this inside a subnet or something. Anyway, let me just rename and I'll finish this. Vertical slice ratios, slice ratios, horizontal slice numbers, minimum window height 1, minimum window height 1, maximum window height 1, max window height 1, minimum. I'll just copy this thing here. 2, max window height 2, max window height 2, max window height 2, minimum window offset, maximum window, oyasumi nasai, window offset, no window ratio. Balcony chance. Washing pole. I don't really think it's called washing pole. I don't know how to call it. And I'll just call it AC chance. AC chance. AC chance. There you go. Okay. Every parameters being set. Let's unpack it. Okay, if I unpack it, it's a bit slow. Since I have tons of geometries, maybe I should pack it to make it an instance object. Oof. Let me just cancel. Oh no. Oh no. In the end, let me check if I could retrieve the crash file. I think I did saved it in the last moment. hopefully I'll be able to get the last result. I think I should enable pack after all. Yeah. And move these color part as well as the UV part before packing somewhere around here. Yeah, that'll do it. Okay, that's it. Thank you very much, and okay, looks good. Max level to 50. Oh, yeah, like a mega city. Okay. Thank you very much and good night. Come back later for the what's this? Wait. I gotta fix this one first. What's happening here? Is it because of the packing maybe? So so I had, what's this? Minimum, center. Okay, so this has been moved here, right, and has been packed, right, and oh wait a minute, I should not have this one. No, not this one. And I should bring this one right after here. There you go. Okay. That's where I was doing wrong. Okay. Sorry for the last hassle, and that's it. Thank you very much. And see you next week with some different topic. おやすみなさい。